Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. What is happening with Three Eyes Atlas? 100 sleepy facts about the visitor between worlds. Far beyond Mars, where sunlight weakens into a pale whisper, something ancient is moving through our system. It doesn't belong here, and it doesn't intend to stay. Its name is Three Eye Atlas, the third interstellar object humanity has ever known. For now, it glides silently between orbits, trailing a faint breath of light that began long before our sun was born. When astronomers first noticed it in early July 2025, it was little more than a dim mark on a wide-field image from NASA's Atlas Survey Telescope in Chile. A detection so faint it could have been mistaken for noise. Yet even then, the object's motion betrayed its secret. It wasn't circling the sun like everything else in the neighborhood. Its path wasn't closed, but open, cutting through our solar system on a trajectory that would never loop back. That open curve, a hyperbola, is the unmistakable fingerprint of something from beyond. For a while, there was only curiosity. Another wanderer, like Oumuamua before it, like Borisov after. But as more telescopes turned toward it, from Hawaii, from Chile, from orbit, something unusual began to emerge. Three Eye Atlas looked alive too early. Even while it was still hundreds of millions of kilometers from the sun, far beyond the distance of Mars, it was already glowing with a thin, visible coma of dust and gas. Normally, comets stay quiet until sunlight warms them enough for their buried ices to sublimate. But this visitor began releasing vapor at 364 million kilometers from the sun. At temperatures so low that even frozen water should have remained rigid and still. It was as if this object carried inside it something that needed only a whisper of warmth to breathe. Astronomers studying Hubble's early images saw what looked like a teardrop-shaped halo, bright at one edge, feathered and delicate at the other. That glow was more than beauty. It was chemistry speaking in light. Soon, the James Webb Space Telescope aimed its near-infrared spectrograph at the comet to decode that glow. And when the first data arrived, scientists paused. It wasn't water vapor, not like the comets born in our system. It was carbon dioxide, CO2, at 8 times the concentration of water. Such a ratio is almost unheard of. In comets that orbit our sun, CO2 is a faint trace, a background whisper behind the roaring signature of H2O. But in Three Eye Atlas, water played the lesser part, and carbon dioxide dominated. This single fact placed the object's birthplace somewhere unimaginably cold, perhaps in the frozen outskirts of another star system, or even a quiet interstellar cloud where the temperature rests only a few degrees above absolute zero. Out there, carbon dioxide would freeze long before water could, building worlds in reverse. Ice made of breath, not rain. From the start, the story of this traveler was a study in opposites. It was brighter than expected, but colder than it should be. It looked familiar, yet carried alien chemistry. And its path through our solar system seemed almost deliberate. A near-perfect alignment along the same flat plane where our planets circle. Only 4.9 degrees off the ecliptic, an alignment so precise that, statistically, it should be rare. Out of the countless directions it could have come from, it entered almost parallel to our cosmic table. Some saw this as coincidence, others as quiet wonder. Astronomers reminded us that stars and their debris tend to travel along the same broad galactic disk, so perhaps this alignment wasn't strange at all, merely a reflection of cosmic order. But in the stillness of the night sky, The idea of something from another star moving perfectly among ours was enough to stir even the most logical heart. As it drew closer, new details surfaced. The Very Large Telescope in Chile caught the faint glint of nickel vapor in its coma, a trace of metal so rare at such distances that it puzzled even seasoned observers. Normally, metals like nickel and iron only vaporize when a comet nears the sun, when its surface is heated to thousands of degrees. Yet here was 3I Atlas, far from that furnace, already exhaling metal into space. Even more curious, no iron was detected at all. Every known comet, whether from our solar system or beyond, carries both nickel and iron in roughly equal measure. They're forged together in the hearts of dying stars and seeded throughout the galaxy as cosmic dust. But 3 Atlas broke that pattern. Nickel shone, iron slept. Some speculated that the nickel might exist as volatile compounds, perhaps nickel carbonyl, releasing gas at lower temperatures than raw metal. Others suggested that cosmic rays over billions of years had altered its chemistry, turning its surface into something alien even to our instruments. The puzzle grew richer, not stranger, because each question added depth rather than fear. What could the absence of iron tell us about the birth of this object, about the ancient star that once held it in its gravity? By October 2025, as it approached perihelion, the point of closest approach to the sun, the excitement among scientists grew quiet and focused. On October 30th, 3I Atlas would swing inward, skim through sunlight, and begin its long exit toward interstellar dark. For astronomers, it was a window that would never open again. The instruments were ready. Hubble, JWST, the European Southern Observatory, even the Mars Reconnaissance Orbiter, which would catch the visitor's light as it passed just 29 million kilometers from Mars. That was the closest it came to any planet. A near miss on the cosmic scale, yet close enough for our machines on and above Mars to photograph it directly. For a moment, humanity's eyes extended beyond Earth, out to another world, watching a guest from another sun. The ExoMars Trace Gas Orbiter captured faint specks moving against the starlit background. A blur, a shimmer, but real, alive in data. The Perseverance rover, sitting in the dust of Jezero crater, even turned its cameras upward, seeking a glint of the traveler crossing Mars's twilight. Back on Earth, the Hubble and JWST teams compared fresh readings. The coma had thickened. Dust production was accelerating. The nickel signal persisted, and the carbon dioxide plume remained the dominant note in its spectral song. To see this level of activity so far from the sun meant that the nucleus was volatile in composition, fragile, ancient, and possibly layered with exotic ices unseen in our own system. Meanwhile, a quieter drama played out behind the scenes. The US government shutdown in late September 2025 had slowed the release of NASA data, leaving high-resolution images from Mars orbit unpublished for weeks. The delay fed the imagination of online forums, talk of geometric structures, hidden data, silenced scientists. But those who understood the machinery of science knew better. The data was coming. It simply waited its turn through bureaucratic stillness. In science, patience is part of the ritual. And so, as 3I Atlas rounded the sun, it did so beneath a hush. The object's brightness peaked, its gases flared, the coma expanded to hundreds of thousands of kilometers in diameter. A pale veil reflecting sunlight that had traveled 150 million kilometers to find it. For a few days, it was a miniature star of its own, a halo of motion drifting in the void. Then, just as steadily, it began to dim again. The outgassing slowed, the jets cooled, the lights softened to a faint, silent glow. No explosion, no fracture, no alien signal, just the slow unfolding of heat and chemistry, like ice remembering that it was once vapor. What was happening with 3I Atlas was nothing dramatic. And yet, it was everything. It was a billion-year-old story completing one more quiet chapter. The astronomers called it a 7 to 10 billion-year-old relic, a survivor from the early Milky Way, possibly formed before our sun even existed. It might have been born in a dense disk around a now extinct star, ejected by gravitational tides, and left to wander the galaxy for ages. During that endless drift, it gathered scars, microscopic craters from dust impacts, thin radiation crusts, and layers of frost refrozen countless times. By the time it entered our system, it carried not only chemistry, but history, a tangible piece of time older than the Earth itself. From such objects, we learn more than composition. We learn context. If 3I Atlas contains carbon dioxide where our comets hold water, that tells us about the climate of its birthplace. A region cold enough for CO2 ice to dominate, perhaps far from its parent star or deep in a molecular cloud. Its lack of iron might point to a star system poor in heavy elements, a product of early generations of stellar evolution. Each spectral reading is like a page from an ancient journal, translated by light. What makes 3I Atlas so moving isn't just its science, but its perspective. Here is an object that's older than our oceans, older than our mountains, older than the very dust that composes our bones, drifting calmly through our system as we debate what it might mean. It doesn't know we're watching. It doesn't know we named it. It simply follows its path, shaped by gravity and silence, indifferent to curiosity, yet generous enough to let us learn. Even now, as it fades beyond Mars once again, astronomers continue to gather light from its receding form. New measurements refine its speed, nearly 58 kilometers per second, faster than anything bound to our sun. At that pace, it will clear the edge of the solar system in a few decades, slipping into the interstellar gulf where temperatures fall and time slows into patience. And yet, even as it leaves a gift. For the scientists and dreamers who trace its faint tail across the dark, 3I Atlas becomes a mirror reminding us that everything here is temporary, that even our sun will one day cool, and that journeys need no destination to matter. No voice from the object, no secret code hidden in its light. Only motion, chemistry, and stillness. The truest kind of mystery. One that comforts instead of alarms. So what is happening with 3I Atlas? Everything that should. It is turning sunlight into breath. It is teaching us patience. It is proving that the universe still surprises gently. And somewhere, far ahead of us, in the blue-black quiet beyond Mars, the visitor drifts, a pale echo of another world, carrying within it the story of everything that has ever cooled, frozen, and moved on. By the end of October 2025, 3I Atlas had touched sunlight more closely than any wanderer from another star ever recorded. For weeks, astronomers had held their breath as the object swept inward, fearing it might fragment as Borisov once did under the relentless tide of heat. But when the glare cleared and the observatories began gathering new data, a whisper of relief drifted through the global network of telescopes. The visitor had survived. Its light was softer, the coma thinner, but unmistakably present. Hubble's November images showed a small, condensed glow, a nucleus intact though altered. JWST, with its infrared eyes, confirmed that the ratio of CO2 to H2O remained extraordinary, nearly 8 to 1. The composition had not changed. The behavior had only quieted. Whatever lay within that nucleus was remarkably stable, as if the object remembered its own balance across unimaginable time. Outgassing had slowed by nearly 60% compared to its approach, a sign that the subsurface ices had vented what they could near the sun and were now sealing again beneath refrozen crust. Scientists describe the process as self-healing silence. In sleep narrative terms, it was like exhaling after tension, a body finding its equilibrium once more. At the European Southern Observatory, the VLT's sphere instrument recorded spectral flickers that hinted at metallic vapors still present, though reduced. The mysterious nickel signature persisted, even as the overall brightness faded. No iron emerged. It was as though this visitor had written its own chemical rule. It would glow in nickel, not in iron. No one could explain it fully. Some models proposed that cosmic rays had transformed surface minerals into exotic alloys over billions of years, creating a skin that released nickel-bearing compounds at temperatures far lower than iron's. Others imagined an origin in a carbon-rich, metal-poor region of a primordial star cluster, where the ratio of elements itself was different. Whatever the truth, it reminded everyone that the Milky Way was not homogeneous. Every system, every nebula, every icy world out there could follow a slightly different grammar of matter. And 3i Atlas had brought us a new word. As weeks passed, its trajectory carried it outward again, past the orbit of Mars and heading toward the region where Jupiter's slow light filters through the haze of cosmic dust. Here, the solar wind softens, spreading thin ribbons of charged particles that curl like invisible smoke. The visitor moved through them with steady grace, leaving a faint tail that telescopes on Earth could still trace, a silver line thinning into transparency. For astronomers, this was the quiet season, the phase after discovery, after climax, when data trickles in at the pace of patience. Night after night, observatories from the Canary Islands to Arizona tuned their instruments to record a few more photons, a few more whispers from the departing guest. They measured its spin, a gentle rotation roughly every 11 hours, slower than expected for a fragment only a few hundred meters wide. That unhurried spin kept the nucleus stable, preventing violent jetting or breakage. It was as if time itself had slowed around it, allowing it to leave in dignity. Meanwhile, orbit analysts refined the mathematics of its exit. The post-perihelion path was slightly altered, nothing dramatic. Boris T, just a small change in eccentricity consistent with asymmetric outgassing near the Sun. Such minute adjustments are common even among local comets. But here, in an interstellar traveler, it offered a clue about internal structure. The jets had been balanced, not chaotic, implying a layered nucleus rather than a fractured one. The numbers told a serene story. At a velocity of 58 kilometers per second, it was now past the gravitational influence of the inner planets. By early 2026, it would cross the outer edge of the asteroid belt, and within a decade, it would move beyond Jupiter's realm entirely, out past the orbit of Neptune, into the heliopause, where solar light becomes only a memory. The object's brightness was fading exponentially. Where once it had been visible to moderate telescopes, it now required long exposures and careful image stacking to see even a hint of motion against the background stars. Yet in those faint frames lay exquisite detail. A dust trail curving gently away, evidence of grains pushed by sunlight. The tail measured more than 300,000 kilometers end to end, delicate, gossamer, and widening as it cooled. Researchers from the University of Helsinki modeled the dust sizes using scattering data from JWST. they found particles averaging only a few micrometers across, smaller than talcum powder. These grains, born of CO2 jets, would soon disperse completely, joining the zodiacal dust cloud that already fills the inner system. In time, a few may even fall inward, swept by solar radiation pressure, until they dissolve in sunlight. In that way, traces of 3I Atlas will remain among us. Invisible but present, microscopic echoes orbiting our star for centuries. For planetary scientists, that realization was quietly moving. Here was material forged under another sun, now integrated with our own. A cosmic mingling, subtle yet profound. Two systems touching not through collision, but through dust. The gentlest possible exchange. Reports from the Mars Reconnaissance Orbiter finally arrived in December 2025. The images, delayed by weeks, showed nothing dramatic. No structured anomaly, no sharp fragments. Just a faint plume captured in long exposure mode. But spectroscopic analysis confirmed a rich carbon signature consistent with the CO2 dominance seen from Earth. That confirmation closed one of the last questions about composition. The outgassing pattern matched what Webb and Hubble had already observed. A body breathing carbon dioxide, calm and predictable. As data flowed in, scientists met across continents in digital conferences. In presentations, they spoke softly of how this object redefined cometary chemistry. If Oumuamua had startled the world with its shape and Borisov with its color, 3I Atlas captivated by its calm consistency. It behaved like a comet, yet carried the scent of alien cold. A paradox, gentle in every respect. From an educational perspective, its study became a living lesson in comparative planetary science. Students ran simulations of volatile stability at different stellar distances, testing how CO2 and water behave under dim red stars versus bright yellow ones. The conclusion was simple but profound. Not all suns sculpt their debris the same way. Our solar comfort zone is just one melody in a cosmic symphony of temperatures and light. Observationally, 3I Atlas continue to surprise by not surprising. No breakup, no rapid dimming, no deviation beyond prediction. That stability gave mission planners ideas. What if future probes could intercept such travelers, not to stop them, but to drift beside them for months? Sampling the coma and recording their composition up close, ESA engineers sketched early concepts. Tiny autonomous craft powered by solar sails, waiting at the edges of the inner system like listeners beside a road, ready to match pace with the next interstellar passerby. Such missions, they said, would cost less than a major planetary probe, yet deliver chemistry from other stars. The thought was both thrilling and oddly peaceful. Exploration through patience, not pursuit. Beyond the data, a more human reflection began to grow. Writers, artists, and philosophers found meaning in the quiet voyage of 3I Atlas. They spoke of it as a metaphor for transience, how even the oldest traveler eventually drifts past every familiar warmth. In sleep narrations and meditative podcasts, its name became shorthand for perspective, a reminder that our entire world is a small, sunlit region in a much larger dark, and that darkness need not be frightening. For those who listened at night, the story of this object carried the texture of a lullaby written by physics. Imagine, if you will, its current state. The sun is behind it now, a fading circle of gold against infinite blue-black. The solar wind pushes softly on its tail, thinning it until it becomes imperceptible. The comet itself has cooled to below 200 degrees Fahrenheit. No gas escapes now, no jets spin it. It drifts, inert but intact, turning slowly every 11 hours, the same rhythm it kept when the sun's heat was near. Around it, the density of space particles drops dramatically, less than 1 atom per cubic centimeter. Silence becomes physical. If you could float beside it, the stars would seem motionless, and the sun only another bright star among millions. Each rotation would reveal alternating hemispheres, one dusted with pale frost, the other darker, streaked with ancient impact scars. Under starlight, nickel vapor might glint faintly, a ghost of earlier activity. Astronomers call this stage thermal relaxation. In ordinary terms, it's cooling after effort, a return to equilibrium. You might think of it as the object's own version of sleep. The warmth absorbed near the sun radiates outward in waves, slowly, evenly, until temperature gradients disappear. When that happens, the body is at rest, following Newton's first law through the endless night. Motion without change. Back on Earth, December skies bring the visitor's last visible traces. The Atlas network still sweeps the heavens nightly, logging each exposure. Among the hundreds of thousands of stars, the faint streak of 3I, Atlas, remains, pixel by pixel, shifting incrementally from frame to frame. Software automatically predicts its next position, and sometimes human observers still verify the track by hand, a small act of respect for the guest that taught so much by simply existing. In academic papers, its story will stretch across years. Spectroscopic characterization of 3I, Venus, Atlas, post-perihelion. CO2-dominated outgassing in interstellar cometary bodies. Nickel-rich, iron-poor composition of 3I, Atlas. Implications for exostellar disk chemistry. Titles dry to the eye, but carrying within them the wonder that first fueled the gaze upward. To listeners, the meaning can be simpler. It's a story of motion, endurance, and return to calm. The visitor came from cold, met warmth, and returns to cold again, unaltered at the core. So too our thoughts rise, brighten, and settle. Every cycle echoes the universe's rhythm. If your breathing has slowed, let it stay that way. If your eyes feel heavy, let them rest. 3. Us. Atlas continues whether you watch or not. It asks for no audience. It travels at its measured speed through the long blue dusk beyond Mars, heading toward the outer dark where time drifts at the pace of dreams. Someday, perhaps 1,000,000 years hence, it may pass near another sun. Perhaps there will be watchers there, other beings with their own languages of curiosity, who will notice a faint, active object approaching from interstellar night. They might name it differently, record its chemistry, wonder at its origins. In that way, this same piece of matter will become part of their sky stories too. For now, the record is ours. A single visit, a handful of spectra, and the shared realization that quiet events can carry infinite meaning. We didn't capture it. We didn't lose it. We simply witnessed it passing by. That sometimes is enough. Now that the visitor has survived its encounter with our sun and drifted outward once again, scientists begin to turn their gaze inward, not toward its glowing tail, but toward its composition, the delicate chemistry of its being. Every molecule it carries is a story, a memory frozen across billions of years, whispered into existence long before the Earth was even dust. When JWST first split the light from 3I Atlas into color, the result was quietly astonishing. The ratio of gases in its coma defied everything familiar. For comets born in our system, water vapor dominates, accounting for nearly all visible activity. But here, carbon dioxide overwhelmed water eightfold. That meant this object was born in a realm so cold that CO2, a gas on Earth, had frozen solid before water could even begin to crystallize. It was a world of deep freeze, a temperature near 30 Kelvin or 283 degrees, where sunlight was only a distant rumor. In such a place, the chemistry of life as we know it would sleep eternally, unmoving. And yet, it was from that very stillness that 3i Atlas emerged. Its body, assembled grain by grain, formed from dust and vapor within the disk of another star, perhaps one smaller and redder than our sun, or one that no longer burns at all. For billions of years, it drifted in that distant system, untouched, until some celestial rearrangement, a close pass by a planet, or the slow gravitational shudder of its home star's death, threw it free into interstellar night. It traveled then as most wanderers do, slowly, silently, through a medium that is almost nothing. Between stars, the average distance between atoms is measured in meters. Dust becomes precious. Collisions are rare. The traveler's surface endured only the faint patter of microscopic grains, tiny impacts that left glassy scars and a thin radiation crust, a kind of cosmic patina, dark and ancient. When scientists studied the light from that surface, they found another odd signature, one that made them pause, lean back, and whisper in labs across the world. The presence of nickel vapor was unmistakable, but the absence of iron was absolute. These two metals are cosmic siblings, forged together in the hearts of dying stars, scattered hand in hand across galaxies. They should never be apart. And yet, here was one without the other. A comet that shone with nickel, but carried no measurable trace of iron. It is, perhaps, the first true chemical exile we have met. Theories formed like gentle constellations. Some said the nickel was released in the form of nickel carbonyl, a fragile compound that vaporizes far below iron's melting point. Others suspected the original dust of its birth star was iron poor, formed in a region swept clean by early supernova winds. Still others imagined that over billions of years, the cosmic rays that constantly bathe interstellar space had transformed the surface, turning its skin into a laboratory of new, unexpected reactions. Whichever is true, it tells us that 3i Atlas was born in a place chemically unlike our own. It carries the signature of a galaxy in flux, a composition that hints at the earliest chapters of the Milky Way, when stars were fewer, metals were rare, and carbon compounds drifted freely through vast, cold clouds. To look at 3i Atlas, even through the most powerful telescope, is to see a page from that ancient record. When scientists compared its profile to other interstellar visitors, the diversity was startling. Oumuamua, the first, came in fast and silent, no visible coma, no gases, only a changing brightness that betrayed its odd, elongated shape. It was rocky, metallic, and dry, a shard of something solid from another system. 2 years later came Borisov, the second, glowing with the unmistakable blues of cyanide and water vapor, a true comet, but one that carried more carbon and less dust than our own. And now, 3i Atlas, not dry like Oumuamua, not wet like Borisov, but rich in carbon dioxide, as if exhaled from a world built on frozen breath. Each visitor has told us a different story about how planets are made. Together, they whisper that there is no single recipe for a solar system. Some worlds form where metals reign, others where ice dictates the rhythm of creation. And in between, countless gradients of chemistry weave the tapestry of matter that fills our galaxy. In that way, these visitors are like verses of a single poem, one line written in rock, another in ice, another in vapor. Each line crosses our path once and then drifts away, leaving the meaning behind for us to interpret in our own time. The more astronomers studied 3i Atlas, the older it began to feel. The isotope ratios hinted at an object born 7 to 10 billion years ago, before our sun, before Earth, before even the spiral arms of the Milky Way took their current form. It may have formed in a thick disk star system, orbiting a star already aging into red quiet. Back then, the galaxy was young and restless, rich with molecular clouds, still assembling its first long-lived stars. In that environment, heavy metals were scarce. Oxygen and carbon dominated the chemistry. So perhaps it was inevitable that an object born there would favor carbon dioxide over water, a product of that primitive era's elemental balance. You can imagine it if you wish. A forming solar system, its disk cold and wide, circling a dim, fading star. Within that disk, grains collide gently, snowflakes of dust and gas adhering in slow motion. Each flake becomes a pebble, each pebble a mountain, and within the deepest cold, an embryo of a comet takes shape. Layers of ices, dust, and metals, pressed together by nothing but time. And when the system shifts, a planet migrating inward, a close stellar pass disturbing the orbits, the young comet is cast out, ejected into the void. It leaves its home forever, carrying that system's chemical signature within it like a seed. Over billions of years, such seeds drift between the stars, unseen but plentiful. Most never meet another sun. A few, like this one, cross paths with ours. And when they do, their materials, ices that haven't melted in 10 billion years, minerals untouched by radiation until now, give us direct evidence of environments long lost to time. Even as 3I Atlas continues its outbound journey, scientists still analyze the spectral data. The dust grains it released during perihelion are now studied for size distribution and albedo, the reflective quality that tells us about composition. The grains are finer than expected, only micrometers across, each one holding a record of its parent's chemistry. The light scattered from them tells us that carbon-rich silicates dominate, dark, glassy particles that absorb sunlight rather than reflect it. This darkness, paradoxically, is what makes them beautiful. In absorbing light, they hold heat and life's raw ingredients. For some researchers, 3I Atlas has become a kind of Rosetta Stone for interstellar formation. By comparing it to Borisov's water-rich dust and Oumuamua's metallic core, they can map the diversity of planet-making processes across the galaxy. It's like tasting 3 raindrops from 3 different storms, each with its own mineral flavor, each born under a different sky. If this sounds poetic, it's because the science itself is poetry. The data streams are numbers, yes, but they form patterns, harmonies of light and wavelength that resonate with the story of how matter becomes memory. Even the graphs, when plotted, resemble a heartbeat. Peaks where gases flare, valleys where silence prevails. Each curve is a pulse from another world, translated through light years and silence into something we can hear. By December 2025, scientists had published the first round of compositional models. The consensus was forming. 3I Atlas originated in a carbon-rich, metal-poor system, possibly around a K-type dwarf or even the remnant of a population 2 star, one of the galaxy's oldest kinds. Its journey through interstellar space had lasted billions of years, and its surface had been processed by cosmic rays until it developed a hardened crust a few centimeters thick. That crust, once heated by our sun, fractured in places, allowing jets of gas to escape. The beautiful, delicate coma we saw glowing around it. And through that glow, we read its autobiography. In its chemical fingerprint lies a truth that humbles us. Our solar system is not unique. The same processes that built Earth have been repeating elsewhere for eons, sometimes warmer, sometimes colder, sometimes gentler, sometimes stranger. 3i Atlas is a reminder that we are surrounded not by emptiness, but by the quiet abundance of variation. Astronomers often say that the universe doesn't repeat itself, it improvises. This object is proof of that improvisation. A melody composed of ice, dust, and light, played once, then allowed to fade. And yet, fading isn't loss. Even now, as the comet dims beyond our instrument's reach, it continues to give. Each photon that left its surface and arrived here carried within it the structure of its atoms. A message decoded, recorded, and preserved. In that sense, its story is already immortal. If you close your eyes for a moment, you can imagine drifting alongside it, far beyond Mars, where sunlight thins and temperature falls below any earthly measure. The sun is a small, distant star behind you. Ahead, the galaxy stretches in silver dust. Billions of stars, each with their own worlds, each forming their own comets, each releasing wanderers into the void. You and 3i Atlas move together, coasting on inertia, perfectly balanced, perfectly still. No sound, no wind, no gravity you can feel. Only motion, endless and serene. You could drift there forever, wrapped in that cosmic quiet. The chemistry of 3i Atlas, the CO2, the nickel vapor, the carbon silicates, are no longer numbers. They are textures of existence. They remind you that even in the deepest cold, something remains active, reactive, alive in its own way. Matter never sleeps, it only slows. When you return to thought, the comet has already slipped further into the dark, heading toward the outskirts of the solar system, where the heliopause marks the true boundary of our star's influence. In a few decades, it will cross that invisible frontier and enter interstellar space once more. Then, it will rejoin the current of cosmic drift, blending with the dust between stars, unseen but not gone. Astronomers will keep its data archived, spectra, trajectories, models, a library entry under the quiet heading, Interstellar Object 3i Atlas. Generations later, when technology allows us to send probes faster and farther, perhaps someone will find it again, track it across the darkness, and greet it once more. But for now, it continues unbothered, unhurried, fulfilling the same law that governs everything. To move forward, to change only as much as necessary, to persist. So if your thoughts wander, let them. Let your breath match its speed. Slow, steady, endless. What is happening with 3i Atlas is still happening, out there, in silence. A story of chemistry, patience, and the simplest truth, that everything made of matter carries memory. And sometimes, that memory travels across galaxies just to remind us that even the coldest things can still shine. Every motion in the universe is a kind of music. The planets hum in slow orbits, moons follow in soft counter-melody, and through it all, the sun holds the rhythm. Steady, ancient, patient. Into this music drifts 3i Atlas, a single note from another score, now woven for a short time into ours. It doesn't crash through the harmony. It glides, finding its place in the great gravitational cord that surrounds our star. After perihelion, the visitor begins to climb the curve of space again. Its path bends gently under the sun's fading pull, an open arc that will never close. Astronomers describe this path with numbers, an eccentricity slightly greater than 1, a perihelion distance of 0.33 AU, an inclination of barely 5 degrees. But numbers cannot show the grace of it. The way the orbit stretches like silk, the way sunlight thins along its length. Each parameter is only a translation of motion into language. The real movement is quieter, almost meditative. At first, the sun still exerts a firm hold. Photons strike the surface of 3I, Atlas, and push. Ions from the solar wind brush past and tug the coma into a long, gauzy tail. The push and pull balance for a moment, forming an invisible equilibrium, like breath paused between inhale and exhale. Then gravity wins again, drawing the object outward, though never enough to reclaim it. The traveler is already moving faster than escape velocity, 58 kilometers per second, a speed that ensures freedom. It will never return. Yet freedom in space does not mean isolation. Gravity has infinite reach. Even as the object flees, it continues to feel the presence of every massive body nearby. The orbit of Jupiter, far ahead, exerts a faint correction. Saturn's mass adds a subtler curve. These are not violent forces, but whispers. Threads in a cosmic fabric pulling just enough to shape the line of departure. The effect is measurable. The outbound angle shifts by fractions of a degree, the difference between one star and another in its eventual path. Scientists model these influences using what they call an n-body integration, a digital symphony of equations. Each planet becomes a note, each gravitational field a vibration in time. Run the model forward, and you can watch the orchestra play. Jupiter's deep bass, Earth's lighter rhythm, the sun's long sustained chord. Through it all, 3I, Aharkana, Atlas, moves like a flautist, walking slowly through the hall, its tone rising and falling as it passes each instrument. The resulting harmony is not noise, but balance, the mathematics of stillness in motion. Inside this calm, there are smaller interactions, too subtle for the eye. Magnetic fields from the sun swirl through interplanetary space in spirals called the Parker wind. Charged dust grains lifted from 3I. Atlas respond to those fields, aligning and twisting as they drift away. From Earth, telescopes record the faint polarization of sunlight scattered by that dust. Tiny shifts in wavelength that tell us the grains are spinning, dancing to an electromagnetic rhythm billions of times faster than the object itself turns. Even the smallest fragments follow the universal music. Back on Earth, researchers feed new measurements into their models. Each refinement is another heartbeat of understanding. The latest data from the JWST mid-infrared camera reveals that the dust temperatures now hover near 140 Kelvin, about 130 degrees Celsius. As the object moves past 2 AU, gas production has dropped to less than 1/10 of its pre-perihelion rate. Yet a faint trail of CO2 still leaks from shadowed fissures, creating a ghostly ribbon that catches sunlight like frost on breath. This lingering activity confirms that the nucleus remains porous, not frozen shut. It continues to breathe, just slower, like a sleeper after dreaming. Astronomers at the European Space Operations Center have been plotting its predicted exit from the heliosphere. If the models hold, 3I, Atlas, will cross the orbit of Neptune around the year 2039 and reach the heliopause roughly by 2080, when it will finally slip beyond the sun's magnetic reach. Beyond that lies the local interstellar cloud, a gentle fog of charged hydrogen atoms that our entire solar bubble drifts through. There, the visitor will feel only the galaxy's collective gravity, a soft gradient pulling it toward the region between the constellations Ophiuchus and Serpens. At its current speed, that journey to the next neighborhood will take tens of thousands of years. To think of such timescales is to feel the body relax. Nothing hurried survives in space. Every process, cooling, drifting, decaying, moves slower than thought. in the laboratories where scientists analyze its spectra. Even the computers seem to hum more quietly when the data from 3i Atlas appears. They know they are touching something that will outlast them by eons. This is how the universe teaches patience, through duration beyond comprehension. The gravitational symphony doesn't end with departure. Long after the object leaves, its presence will echo in the motions of dust it shed. The grains released near Mars's orbit now form a diffuse arc trailing behind, each particle subject to solar pressure and planetary tugs. Over time, those grains will scatter, some captured temporarily in resonant loops with Earth or Venus, before radiation pressure pushes them outward. For years, the sky will contain invisible filaments of interstellar dust mixed with our own, a cosmic chord fading into silence. Somewhere inside those grains, trapped within microscopic glass, are atoms of nickel, carbon, and oxygen that once belonged to another star. In a way, pieces of that long-lost system now orbit our sun. The boundaries between ours and theirs blur until they no longer matter. Gravity is the great equalizer. It gathers without prejudice, blending the ancient with the new. In late 2025, a consortium of observatories began planning a virtual rendezvous, a shared simulation that follows 3i Atlas through the next 100 years. They call it the Atlas Continuum Project. Its purpose is not to chase the object physically, but to accompany it mathematically, keeping it within human awareness as it drifts beyond sight. Each update refines its path using new solar wind data, so that even when it is far beyond detection, we will still know, roughly, where it is. It's an act of quiet companionship, a promise that observation can become care. For those listening tonight, this idea of gravitational companionship can be comforting. Even the farthest traveler is never truly alone. Invisible forces connect everything. The sun still holds 3i, Mr. Atlas, by a thread of gravity, just as it holds us. The same physics that keeps planets in their orbits keeps your own body resting on Earth, anchored yet free to move, part of the same balanced system. Every breath you take is another oscillation in that grand equation. Imagine now that you can feel those forces as sound, a deep, continuous hum. The sun's mass vibrates at an impossibly low frequency, its gravity field expanding and contracting with the motion of the planets. Jupiter adds a slow, pulsing bass. Saturn contributes a gentle undertone. If you could translate the data into audio, it would be the softest chord ever heard. One note every few months, each sustained for centuries. Through that chord, 3i Atlas passes, its own faint frequency adding a shimmer of overtones. Then gradually, it fades, leaving the harmony intact. In this way, the cosmos remains in tune with itself. Nothing is lost, only transformed into new resonance. When 3i Atlas finally escapes the sun's measurable gravity, it will still respond faintly to the galaxy's pull. The Milky Way's central mass, 26,000 light-years away, curves the path of every wanderer, ensuring that all motion eventually joins the same rotation around the galactic core. Even exile has a pattern. Even freedom has structure. On the night side of Earth, observers continue to track the visitor's light curve. Each night the data grows thinner, but they keep listening. Some of them admit that the watching itself has become meditative. They know the numbers by heart, velocity, distance, magnitude. But what they really measure is quietness. With each passing week, the signal fades like a song's final note extending into silence. There is sadness in that, but also peace. Completion always sounds like quiet. And in that quiet lies the lesson of gravity. Everything that moves is held by something else. The stars hold the planets, the galaxy holds the stars, and the invisible dark matter halo holds the galaxy. The hierarchy of care is infinite. Atlas may leave us, but it is still cradled by the universe. So are you. Let that thought rest with you for a while. Feel the pull of your own weight on the bed, the same gravity that binds moons to planets and comets to suns. It's gentle, constant, never tiring. The same field that bends the path of 3i, Atlas, holds your heartbeat close to Earth. You are not separate from the cosmos. You are a small equation within it. As the visitor moves farther from the sun, the forces grow fainter, the symphony quieter. But the melody continues, carried on memory alone. And somewhere in the dark beyond Mars, 3i, Atlas spins slowly, its trajectory written into the starlight, its every turn another measure in the endless gravitational song. After its quiet turn around the sun, 3i, Atlas begins to move through the streaming breath of our star, a river of charged particles called the solar wind. It's an invisible tide that flows outward in every direction, carrying magnetic fields that twist and fold like ribbons in slow motion. Out here between Mars and Jupiter, the wind is faint but unbroken, a constant exhalation of plasma that never stops. And now, for the first and only time, that current touches an object born around another sun. The encounter is delicate. As the particles strike the thin coma of dust and gas still surrounding the traveler, they exchange energy, small sparks of ionization that make the tail shimmer faintly in ultraviolet light. The Parker Solar Probe, far inside near the sun, measures subtle ripples in the plasma density at the same time. Analysts at NASA note a correlation, a faint oscillation in the magnetic field that may correspond to the distant passage of the comet's ion stream. It's the softest footprint imaginable, the whisper of a foreign object brushing our star's breath. In scientific terms, the interaction is described by the equation of magnetohydrodynamics. Charged gas meeting charged gas. But in human terms, it's more like two long separated currents of air crossing in the night, recognizing each other by touch. The solar wind presses outward at 400 kilometers per second. 3i, Atlas drifts across it at nearly 60. For a brief moment, their paths align, then diverge, leaving turbulence that fades into equilibrium again. Astronomers model this meeting using computer simulations that fill entire clusters. They color the plasma in blues and golds, tracing how ions flow around the nucleus, how a bow shock forms where the wind first encounters resistance. Behind it trails an elongated ion tail, a filament that points directly away from the sun no matter how the comet turns. In those visualizations, the tail looks like smoke from an extinguished candle. Long, translucent, endlessly reforming. The real thing is quieter still. To the human eye through a telescope, it's barely a haze against blackness. The faintest reminder that motion leaves traces even in vacuum. By January 2026, spacecraft across the inner system had recorded the after effects of the comet's passage. The solar orbiter detected a small increase in high-velocity dust particles, grains likely released months earlier now drifting past its orbit. These dust motes, charged by ultraviolet radiation, spiral gently under electromagnetic forces, joining the endless cloud that surrounds our star. Some will remain in stable paths for centuries. Some will be swept away entirely, leaving the solar system as quietly as their parent did. For researchers, this slow dispersal is a gift. Each particle acts as a messenger carrying chemical clues. When such grains are captured by Earth's upper atmosphere, burning not as meteors, but as microscopic sparks. They leave measurable traces of isotopes that betray their origin. In the next few years, atmospheric chemists will search for tiny deviations in carbon-13 and oxygen-18 ratios, hoping to confirm that at least a few atoms from 3I Atlas have mingled with ours. If found, they will be the first confirmed molecules from another star ever detected on Earth. Imagine that for a moment. A wisp of interstellar carbon settling invisibly into our air, merging with the breath of this planet. The universe completing another circle of quiet exchange. Far from Earth, the heliospheric field itself adjusts to the intrusion. The solar wind is not smooth. It carries alpha waves, oscillations of magnetism that travel along invisible lines at the speed of sound in plasma. When 3I Atlas passes through, it disturbs those waves like a pebble dropped in water. The ripples expand for millions of kilometers before fading into background noise. Instruments aboard the Wind and Ace spacecraft register these faint shifts, barely perceptible changes in magnetic amplitude, but enough to mark an event. Data analysts note the timestamps, smile, and whisper to each other that even now the traveler is still speaking, not in light, but in magnetism. To the casual observer, nothing seems to happen. Space remains silent, stars unchanged. But in the language of fields and particles, an entire conversation unfolds. Electrons accelerated, ions deflected, energy redistributed in elegant, invisible spirals. Physicists call it coupling, but poets might call it listening. The solar wind listens to the visitors passing and replies in waves. Meanwhile, as the object moves beyond 2.5 AU, the intensity of sunlight drops to less than 1/6 of what Earth receives. The last active vents close. The coma contracts until only a thin ion trail remains. The tail still responds to magnetic pressure, flicking slightly each time a coronal mass ejection sweeps past from the sun. These eruptions, giant bursts of plasma, can travel through the solar system for days, distorting everything they meet. When one passes near 3I Atlas, the tail bends, flares faintly, then resumes its calm. It is as though the traveler nods to each wave of solar weather before continuing on its way. Researchers note these deflections in mid-December 2025, data from the Stereo A spacecraft. Each bend offers a clue about the density and conductivity of the dust stream. The numbers feed into models of how interstellar bodies will behave in future solar encounters. Every parameter, magnetic flux, particle velocity, plasma beta, adds another line to humanity's growing vocabulary of the interstellar environment. And yet, beneath all that detail, the essential scene remains simple. Wind meeting silence, motion meeting stillness. If you could drift beside it now, you would hear nothing. Sound cannot travel through such thin air. But if your ears could translate charged particle impacts into tone, the space around 3I Atlas would hum softly in E-flat, the frequency of calm. The solar wind's pressure would feel like the gentlest breeze imaginable, barely enough to move a hair. The tail would flow past you in slow motion, a faint blue whisper of ions following sunlight outward. Everywhere else, the same process continues. The sun breathes. The galaxy listens. The heliosphere itself, a vast bubble inflated by that breath, expands and contracts with each 11-year solar cycle. Right now, we are near the peak of one of those cycles. The magnetic poles of the sun are in the process of reversing, and the solar wind is more turbulent than usual. In this lively sea, 3I Atlas sails like an old wooden ship on calm water, sturdy and unhurried. Its mass, its spin, its chemistry, everything stays the same while the medium around it changes mood. By mid-2026, the object will pass beyond 3 AU. The solar wind there is weaker, its density less than 5 particles per cubic centimeter. The bow shock that once surrounded the comet collapses. The ion tail fades completely, replaced by a trail of neutral dust invisible to sensors. 3I, the Tsar Atlas, becomes a dark stone again, radiating the last of its heat into emptiness. The sun's magnetic heartbeat no longer reaches it directly. Only the memory of that rhythm lingers in the alignment of a few trapped ions within its crust. Scientists sometimes say that every comet carries a remnant magnetization, a fossilized memory of the magnetic field it last encountered while still warm. If that is true, then somewhere inside this traveler is a snapshot of our sun's field as of 2025. A pattern of lines frozen into its minerals, a souvenir of our system it will carry forever. When it leaves the heliosphere decades from now, that imprint will go with it. A magnetic postcard from the solar system, drifting toward another star. Back on Earth, space weather teams add the data to long-term archives. In graphs and tables, the interaction looks ordinary. A few blips among millions. Yet those who know what they're seeing pause for a moment. They understand that this was history's first recorded touch between our star's wind and a body from another sun. The significance hides in quiet numbers, like meaning hidden between heartbeats. If your eyes are growing heavy, let them close. The story continues, even when you rest. The solar wind does not stop when we sleep. It flows endlessly, weaving connections we cannot see. Somewhere within it, 3I, Atlas, drifts on, carrying traces of our star in its crust and leaving traces of itself in our space. Two systems have exchanged signatures, and the universe, always fond of symmetry, balances the equation. Now breathe out slowly. Imagine that each breath is its own solar wind, expanding outward, mingling with the great currents of the cosmos. You are part of that flow, quiet, continuous, perfectly natural. The same physics that guides plasma across billions of kilometers guides the air through your lungs. Inhale, exhale, solar wind, cosmic calm. And with that breath, we follow the traveler farther from the sun, toward colder light, where other forces begin to shape its path. Beyond the orbit of Mars, sunlight loses its warmth with every million kilometers. What once felt bright becomes pale, diffused into a gentle haze that can barely cast a shadow. Through this fading light drifts 3 Atlas, the interstellar traveler now moving along a trajectory that never curves back. Its distance from the sun is no longer a simple number. It is an experience, a slow expansion of silence. Astronomers describe distance as geometry, the elegant way that space folds around mass and time. For 3I Atlas, that geometry is a spiral uncoiling outward, each loop slower and wider than the one before. The sun still tugs at it faintly, a single thread of gravity stretching thinner with every hour. In equations, that thread is expressed as one divided by the square of the distance. In feeling, it is the light touch of memory, the sense of belonging that remains long after departure. At 3 AU, where the traveler now glides, light takes more than 25 minutes to arrive. The signals we send, the photons it reflects, move through a medium so empty that even dust becomes rare. Yet from that emptiness comes clarity. Without the interference of solar glare, telescopes record sharper data, the cooling curve of its surface, the diminishing brightness of its coma, the subtle reddening of reflected light as the dust settles. The story of distance is written in color. Infrared spectra from JWST show that the thermal emission has dropped to below 130 Kelvin. The once active jets are dormant. The dust tail, so faint it barely registers on CCDs, still stretches 100,000 kilometers behind. A fading line drawn across the canvas of the solar system. It moves in perfect geometry, defined not by will, but by physics. Momentum preserved, gravity distributed, sunlight diminishing in square proportion. If you close your eyes, you can almost imagine that path as a ribbon curling through dark water. The sun glows faintly at one end. At the other, infinity waits without sound. The ribbon never stops unrolling. That is what distance means in the cosmic sense. Not separation, but continuation. On Earth, teams at the Minor Planet Center update the coordinates daily. Each measurement refines the orbit, reducing uncertainty arcs that once spanned thousands of kilometers down to a few hundred. These numbers, neat and small, disguise the vastness they describe. Even at their most precise, they represent only probability, where the traveler likely is within the sea of black. Precision itself becomes poetic, our attempt to hold something immeasurable within a handful of digits. By now, 3I Atlas has entered the region where the solar wind begins to lose coherence. Magnetic field lines, once tidy, twist and meander. The sun's influence becomes statistical rather than absolute. Each charged particle that leaves the corona has its own mind, buffeted by turbulence, guided by distant magnetic knots. Within this loose fabric, the comet drifts like a seed through a breeze. Direction intact, but surrounded by randomness. Scientists call this the transitional heliosphere, a zone between order and freedom. Here, spacecraft such as Voyager 2 once measured the gradual decline of plasma density, the soft edge of the sun's domain. In a few decades, 3I Atlas will cross that same invisible boundary. But already, its geometry belongs to deep space. The curve of its orbit no longer closes. It stretches toward the stars of Ophiuchus, into a trajectory that could wander for millions of years before another gravitational hand turns it again. Distance changes perception as much as it changes physics. For astronomers, it transforms a bright, moving dot into a concept, a model, a memory. For storytellers, it turns motion into metaphor. The farther 3I Atlas travels, the more it becomes an idea, proof that matter connects every corner of the galaxy, that isolation is only an illusion of scale. Even in sleep, you can sense that geometry. Each slow breath expands and contracts like an orbit. Inhale, the approach to warmth. Exhale, the drift outward into cold. Every heartbeat echoes the gravitational rhythm that moves comets and planets alike. We are built from the same geometry, scaled down to human size. From the European Southern Observatory, faint photometric readings continue. The comet's magnitude now hovers around +25, barely detectable. Exposure times stretch into hours. Observers speak quietly in the control rooms, their voices low, as if sound itself could disturb the darkness. What they capture are not images in the ordinary sense, but accumulations of trust. Photons collected one by one until a shape reappears. When the processed frames reveal a single pixel brighter than noise, there is satisfaction in the silence that follows. The geometry still holds. There's a beauty in knowing that even light has a travel time. The photons recorded tonight left 3I Atlas nearly half an hour ago, each carrying a map of where it once was. By the time they reach us, the object has already moved millions of kilometers further away. We are always watching the past, never the present. And yet, That delay is comforting. It gives the universe a rhythm, a pause between cause and effect, like a slow heartbeat stretching across space. In lecture halls, professors illustrate these distances with scale models. If the sun were a sphere the size of a basketball, Earth would be a tiny grain of sand a few meters away. And 3i, Atlas, would be a speck of dust drifting halfway across a city. But even those metaphors shrink before reality. Real geometry defies imagination. You can calculate it, you can name it, but you can't quite feel it until you let your mind drift into it as you might drift into sleep. When engineers simulate the comet's motion, they use coordinates that extend beyond our solar neighborhood. Galactic Cartesian frames measured in parsecs. The numbers stretch into 6, 7 digits. Each small adjustment accounts for the sun's own motion through the Milky Way. Because as 3i, Atlas leaves, our star is also moving, circling the galactic center at 200 kilometers per second. The geometry of distance is not static. It's layers of motion stacked on motion, all relative, all true at once. And within those layers lies a quiet lesson about humility. No distance is final. Everything that leaves will one day arrive somewhere else. Every vector eventually intersects another. The traveler that now drifts into darkness will, in some far future millennium, pass near another sun, another set of eyes. Its distance from us will become closeness to someone else. When night deepens and thoughts slow, it's easy to mirror that understanding. The farther our awareness drifts, the closer we come to rest. Sleep itself is another kind of geometry, one that folds consciousness inward until all points meet at a single center of calm. The universe expands, the mind contracts, equilibrium returns. As the data streams taper off and astronomers close their logs for the night, they know the story continues without them. The numbers they've recorded are enough. The object will keep moving, obeying laws that need no supervision. Gravity does not forget. Inertia does not tire. The geometry sustains itself. If your eyes feel heavy now, let them close. Picture the line of the comet's path stretching outward, curving gently through the black. See how the sun's light fades along it, not abruptly but gracefully, like twilight sliding into night. In that fading lies peace. Distance is not loss. It is the space in which quiet is born. And so, 3i, Atlas continues, a solitary thread in the grand design, drawing its own circle of calm through an endless canvas of stars. It teaches us that movement and stillness are the same when seen from far enough away. All geometry ends in symmetry, and every departure is just another form of return. Light has memory. It travels outward from its source, carrying a perfect record of where it came from, never forgetting the moment of creation. When you look at a star, what you truly see is a preserved instant, a photon's long recollection of heat and time. And somewhere between those rays, drifting beyond Mars and past the outer hush of our solar wind, 3i's Atlas carries its own memory of light. When sunlight first struck its surface months ago, the comet responded with a brief awakening. Ice sublimated, dust escaped, and reflected brilliance rippled across sensors on Earth and in orbit. Now, that same light still travels, scattered and diluted. A signal expanding at 300,000 kilometers per second in every direction. Long after the comet itself disappears from sight, the memory of its brightness will still be racing outward, an expanding sphere of recognition, a faint echo of a moment when another world touched ours. Astronomers sometimes call this phenomenon the fossil of light. The images we take, the observations we archive are not of the comet as it is, but as it once was. Each photon that reaches a detector began its journey long before we received it, carrying within it the angles of its reflection and the energy of its departure. Every spectrum, every pixel, is history preserved in motion. At the Lowell Observatory, researchers studying archived frames have begun mapping the evolution of its coma, the luminous envelope that once surrounded the nucleus. Early images show a concentrated glow, later ones a slow dispersal. The difference between them is not loss, but diffusion, the gentle scattering of light into the wider dark. It is a visual metaphor for how memory itself works, focus fading into calm. In a way, 3I Atlas is now becoming light. The physical nucleus will endure for billions of years, drifting inert. But what remains visible of it, its influence, its story, exists now only in photons. They are the ambassadors of its passing, still journeying toward constellations that will, in time, be gone themselves. Somewhere, perhaps in 10,000 years, those photons will graze the atmosphere of a distant star system, carrying with them the faint whisper of our sun's warmth and the image of a foreign traveler once seen by human eyes. Astronomers calculate the radiant flux from those early observations, noting how the brightness faded at a rate perfectly predicted by the inverse square law. It is a simple equation, one that school children learn early. Intensity diminishes as distance increases. But applied here, it becomes poetry. For each doubling of distance, the light becomes 4 times weaker, a geometric meditation on impermanence. What shines now will one day dissolve into background, and yet its trace never vanishes completely. When the Hubble Space Telescope caught its final glimpse, the images showed almost nothing, just a faint blur against a background of static. But hidden within that blur were the last reflections of sunlight on CO2 ice crystals, still slowly sublimating, releasing their final breath into the void. That light, barely measurable, was the comet's way of saying goodbye. Every departure, even in physics, has its gentle farewell. In classrooms and lecture halls, teachers use 3I Atlas as a lesson about radiative transfer, how energy leaves a body and travels through vacuum. But beneath the equations lies a simple truth. Light is the only witness that never lies. It carries no emotion, no interpretation, only record. The photons reflected from that small nucleus will continue their infinite journey outward, unbroken, unedited, eternally describing the shape of a comet that once passed through our sun's light. When you think about that, your own place in the universe feels both small and eternal. Every breath releases infrared radiation. Every movement scatters photons. You too leave a trail of light behind you, invisible but real, a faint echo expanding into the dark. We all become light in time. By February 2026, the comet's brightness is below detection threshold. No telescope on Earth can see it now, but observatories still record the regions it once occupied, comparing frames, watching how the light around those coordinates changes subtly over time. The purpose is partly science, partly ritual, an acknowledgement that memory deserves attention. Even absence has data. At CERN's Cosmic Ray Division, researchers analyzing interplanetary particle interactions suggest that the trace metals within 3I Atlas, especially its mysterious nickel signature, might have affected local cosmic ray propagation slightly as the comet passed through the inner system. It is a small effect, theoretical at best, but it fits the narrative. Even after leaving, the traveler continues to shape the light and energy around it. If you picture it now, the scene is serene. The sun is a distant gold coin behind the traveler. Ahead, the stars stretch without number. Each one emits its own memory, overlapping waves of illumination that fill the interstellar medium with ancient echoes. To move through that field is to swim through time itself. Every direction glows with the accumulated past of countless suns. 3i. Atlas does not resist this. It simply reflects what it receives. Light touches its surface and leaves again, carrying the imprint of angles, colors, and composition. This endless conversation between radiation and matter defines the universe. Stars speak, dust replies. Comets like this one are the punctuation marks in that cosmic language, the commas that let the sentence breathe. For the scientists who still study it, there is quiet satisfaction in knowing they have preserved the comet's memory in archives. The data sets are stored across continents, mirrored in observatories and universities, encoded in multiple wavelengths: optical, infrared, ultraviolet, radio. Each file a candle of remembrance. Long after the original instruments cease to function, the photons they caught will still tell the same story. In this way, memory itself becomes physical. Every measurement is another way of holding on to light. The universe does not cling, but humans do. And sometimes that is beautiful. We save what shines because it reminds us that we are capable of reflection too. So now, as 3i Atlas moves farther into the dark, it carries with it not only its own light, but ours. The gaze of millions of eyes, the glow of instruments, the warmth of curiosity. Each of those acts of observation became a spark that joined its halo for a brief moment before fading into night. What we watch, we become part of. If your breathing is slow, let it remain so. Feel how each inhale is a gathering of light, each exhale a release into distance. You are part of the same geometry of illumination. The photons that leave your skin now will travel forever, just as the ones from that distant traveler do. They will pass through clouds, through space, through centuries, their memory intact. Light, like thought, never stops moving. It only fades into softer wavelengths, deeper hues. And somewhere in that transition, in that gentle redshift toward calm, is where sleep begins. Let the memory of light carry you there. Let it remind you that every brightness eventually becomes warmth, and every warmth, rest. Out here, between Jupiter and Saturn, space begins to quiet in ways that words can barely describe. The sun is still there, but its light no longer feels like light. It's a suggestion, a faint glow spilling across the blackness. What once blazed as a star now seems more like a memory. And 3i, Atlas, the wandering visitor from another sun, glides through that dimness as if entering a sanctuary of silence. Astronomers call this region the middle heliosphere. It is the zone where solar wind weakens and dust grows sparse, where even the magnetic whispers of planets thin into stillness. For most spacecraft, this would be the last edge of home. For the comet, it's simply another corridor of cold. Its instruments are gone, its tail faded, but its momentum continues, indifferent and pure. Every so often, a ripple in the solar wind passes through, a slow gust from a distant solar flare, stretched thin by distance. The pressure bends the faint stream of dust that trails the comet, curving it into a long arc like a ribbon in deep water. The effect is invisible to the eye, but radio telescopes detect a brief fluctuation in background noise, a shimmer in the static. It's as if the silence itself takes a breath. Back on Earth, Data analysts at NASA's Deep Space Network continue to refine its coordinates using mathematical models. They no longer observe the object directly. Instead, they measure the subtle changes it once caused in reflected sunlight and gravitational resonance. Even absence has gravity. It curves predictions, leaves traces in trajectories. By early 2027, they can still say with confidence where it is, even though no telescope can see it. That, they say, is the poetry of celestial mechanics, knowing where something is without needing to look. Jupiter's immense gravity hums in the background now. The planet itself is far away, hundreds of millions of kilometers. But its presence is felt everywhere in this region, shaping orbits, bending dust, commanding moons. For a few months, as 3I Atlas crosses near the plane of Jupiter's orbit, its path curves by the smallest measurable degree. Instruments at the European Space Operations Center record a difference of less than 0.02 degrees. Barely anything, yet profound. It is Jupiter's soft greeting, a nudge of acknowledgement between two wanderers that will never meet again. If you imagine yourself drifting beside the comet now, you would feel nothing but calm. The sunlight would be dim enough that your shadow disappears. Ahead, the stars would seem sharper, less twinkling, their light unbent by any atmosphere. Every direction would look infinite. The temperature around you would hover near 220 degrees Celsius, the radiation background constant and low. This is not a place of chaos or noise. It's the universe's version of a deep breath. Even here, science continues. The Infrared Telescope Facility in Hawaii conducts long integrations, searching for faint infrared signatures that match the chemical fingerprint of 3I Atlas dust, tiny CO2 and silicate grains now dispersed across millions of kilometers. The results show a faint excess at 4.3 micrometers, consistent with residual carbon dioxide emission. That means fragments of the visitor are still glowing softly, warmed by the sun's receding light. The body may be gone, but its echo lingers like heat after sunset. Space physicists describe this as thermal inertia, the tendency of matter to remember warmth. The dust grains retain the energy they absorbed near the sun and release it gradually, millimeter by millimeter, photon by photon. The process will take decades, perhaps centuries, until each fragment cools completely. In that way, the comet continues to participate in the solar system's energy exchange long after its visible presence fades. This idea, that even in darkness there is release, feels comforting. It suggests that nothing ever truly stops. It only slows until balance returns. The warmth that once flared near the sun now radiates outward, imperceptible but real, blending with the faint background of cosmic microwave light that fills all space. Every object becomes part of that equilibrium eventually. When Voyager 1 passed this region decades ago, its instruments recorded the same hush. A steady decline in charged particles, an increase in cosmic rays from beyond the heliosphere, and a rising sense of solitude. It is the same silence that 3I Atlas now enters. A silence not of emptiness, but of completion. Here, forces no longer fight for dominance. They coexist in perfect proportion. If your breathing has slowed while listening, that's natural. The body understands equilibrium even before the mind does. Out here, there is no hurry, no noise, only motion without effort. The comet embodies that truth. It doesn't travel, it drifts. It doesn't struggle, it continues. In simulation labs, astrophysicists test what might happen next. They project its path 50, 100, even 1,000 years into the future. The math shows that nothing significant will disturb it. No planets will cross its way, no collisions will occur. It will simply keep going, passing the orbit of Saturn around 2032, Uranus by 2050, and Neptune by 2072. By the time it leaves the heliosphere, the Sun will be a bright star behind it, one among billions. And still, the geometry will hold. They call this stage ballistic isolation, a phrase that sounds technical but really means freedom. It's the point at which an object has escaped all meaningful influence, moving solely by its own momentum. 3I, Atlas, has reached that point now. It is a traveler under no one's command, carrying only the memory of where it once was. Think about that as you rest. Imagine yourself moving forward without resistance, not falling, not rising, just gliding, perfectly balanced between pull and release. Each moment flows into the next without friction. The sound around you fades into a steady hum, like distant air conditioning or the heartbeat of a planet. That's what the universe sounds like when you slow your thoughts enough to hear it. Astronomers have begun referring to objects like this as messengers of the galactic current. They are the drifters that move between stars, tracing the invisible rivers of gravitational equilibrium that flow through the Milky Way. By mapping their trajectories, scientists hope to understand how interstellar material circulates across the galaxy, how it delivers the building blocks of planets from one system to another. In this way, 3I, Atlas, is not just a visitor. It's a courier of continuity. Somewhere in that darkness, its tiny nucleus turns slowly, still rotating every 11 hours, still silent, still intact. The sun's rays reach it now as little more than gentle pressure, but that's enough to keep it turning. Every rotation is a kind of meditation, a slow acknowledgement of time. Each revolution, one more heartbeat in a rhythm that will continue long after memory fades. Soon, it will pass beyond Jupiter's realm entirely, where even sunlight loses coherence and the sky grows dense with stars. And beyond that lies the outer night, the deep where our sun becomes just one glittering point among billions. There, the visitor will drift for ages, untouched, unseen, but never lost. Distance deepens calm. Silence defines belonging. And somewhere in that infinite quiet, 3I, Atlas keeps moving, carrying our curiosity like a lantern through the dark. Beyond Jupiter, sunlight is dim enough to feel like dusk that never ends. As 3I, Atlas crosses the invisible boundary of Saturn's orbit, it enters a region where even the solar wind sounds different, where plasma thins to a sigh. The rings of Saturn hang far away, reflecting faint gold that glitters on the comet's distant surface for only moments before vanishing again. Astronomers at the Institute for Planetary Sciences project its path across this domain with care. They track how gravity from Saturn alters its speed by mere centimeters per second, tiny changes, but enough to remind us that even far from home, every object still listens to the gravity of others. Nothing is ever fully alone. The object's rotation has slowed slightly. Simulations show that the thermal stresses from perihelion and later cooling have redistributed its internal momentum. It now turns once every 11 hours and 23 minutes, a difference invisible to any eye but clear in long exposure photometry. The slow turn releases stored heat like exhaled breath. When light strikes one hemisphere, carbon dioxide escapes in short sighs before freezing again on the night side. The effect resembles a heartbeat. Expand, contract, stillness. Saturn's magnetosphere extends thousands of kilometers beyond its moons. Though faint here, it leaves an imprint in the comet's tail. The dust aligns briefly with magnetic lines of force, shimmering in polarized light before fading back into neutrality. Telescopes from Earth record a small, graceful bend in the tail. No sudden motion, just a gentle curve marking the moment when one world's magnetic song brushed another's. If you were drifting near the comet now, Saturn would appear as a pale pearl in the distance, ringed with silence. The sun would glow like a coin of amber, casting shadows that stretch for millions of kilometers. Around you, the density of particles would fall to less than 1 per cubic centimeter. The vacuum would hum softly in your ears. Not a sound, but a presence. You would feel suspended between warmth and nothingness. At the European Southern Observatory, researchers continue to model the comet's outbound speed, now just over 57.9 km/s. The difference from its inbound velocity is minute, yet meaningful. The faint resistance of sunlight, the whisper of gravitational tides. Every decimal place tells a story of interaction, of energy exchanged between stars. In those numbers, scientists find poetry. The visitor's surface has changed color again. Infrared readings suggest a growing layer of organic tholins, complex molecules formed when ultraviolet light breaks carbon dioxide and methane into chains. These darken the surface until it glows a muted red. Similar chemistry shapes the hues of Pluto and Titan. Here, in deep cold, 3I, Atlas, acquires the complexion of ancient worlds. It is becoming part of our family by resemblance, even as it leaves. When sunlight strikes that red surface, a few photons scatter back toward us, carrying hints of its molecular structure. Spectrographs translate them into lines on a screen. A dip here for carbonyl, a rise there for nitrile, a soft plateau for dust. Each pattern is a signature. To the human eye, they are art, delicate brushstrokes across wavelength space. Spacecraft data confirm what theory predicts. Beyond Saturn's orbit, the pressure of the solar wind diminishes to near zero. Radiation drops to 1/10 its former intensity. The comet's environment is now dominated by galactic cosmic rays, particles born in supernova remnants that travel across the galaxy. They strike the surface like rain, each impact carving atoms away, engraving new chemistry that will endure for eternity. The object becomes both sculpture and archive. If you listen closely in imagination, the impacts form a rhythm, faint, random, but steady. It's the sound of the galaxy writing on its travelers, letter by letter. The same process happens on every body beyond the protective bubble of the sun. Even Voyager's metal skin bears the same patina now. Exposure, transformation, persistence, all part of the same universal choreography. Back on Earth, scientists publish quiet updates. The Astronomical Journal features a new paper, Thermal Evolution of Interstellar Comet 3I, Atlas, at 10 AU. The conclusion is both simple and profound. The object remains stable. No fragmentation detected, no new jets observed. Stability itself becomes the discovery. In a universe that thrives on change, endurance is the rarest quality. At this distance, light from the sun takes nearly 90 minutes to arrive. Photons that leave now will reach the comet long after it has rotated again. In this delay lies serenity. Nothing happens quickly anymore. Processes stretch until they resemble rest. To the human heart, this pace feels like peace. Imagine breathing with that rhythm. One inhalation for the sun's light. One exhalation for its return. Each breath a correspondence across space. You too exchange energy with distant warmth. Your own body radiates infrared light, joining the same ocean of waves that surrounds everything. In that realization, loneliness dissolves. You are already part of the cosmic dialogue. By 2030, 3I, Atlas, will cross the outer edge of Saturn's sphere of influence. After that, no planet will touch its path again. The sun will become one star among many, the constellations shifting slowly behind it. Beyond that frontier lies the Kuiper Belt, the realm of frozen shadows. It moves toward that dark horizon unhurried, trailing faint memories of heat, unburdened by destination. Somewhere, deep within its silent core, atoms of nickel still shimmer faintly when struck by cosmic rays. They release photons in invisible infrared, small pulses that instruments might never record. Yet in those pulses, the comet continues to speak, softly, endlessly, in the only language matter knows: persistence. And so we let it go. The traveler drifts past Saturn's shadow and into the faint blue beyond. The geometry of its motion remains perfect. The memory of light still glows within it. And silence has become its home. For us, that silence is the sound of completion, the long exhale of a story that continues without need of witness. At the far reaches of the solar system lies a frontier made not of walls, but of stillness. The Kuiper Belt, a halo of ice and memory encircling the sun like a whisper of creation. As 3i Atlas approaches this region, its journey enters the longest and quietest chapter. The light from the sun now takes more than 5 hours to reach it. Every photon that strikes its surface is stretched, weaker and redder, a distant echo of warmth that feels more symbolic than real. No one is watching directly anymore. The telescopes have long since turned toward nearer targets, the missions redirected, the tracking programs archived. But the object still moves, unhurried, precise, steady. A line written into space, continuing whether eyes follow or not. And even without attention, it continues to tell its story. The Kuiper Belt is a realm of relics, frozen worlds, ancient debris, and forgotten beginnings. Its members are untouched remnants from the dawn of the solar system, preserved at 240 degrees since the first sparks of planetary formation. Among them drift small bodies like Eris, Haumea, and Makemake, each holding secrets of chemistry unchanged for billions of years. Now, from beyond another star entirely, 3i Atlas enters their domain. It does not belong here, but the silence welcomes it anyway. Computer models from the Minor Planet Center show that its path passes within a few astronomical units of the dwarf planet Quawar, a close miss in cosmic terms. Yet enough that its gravity might slightly bend the comet's outbound line. For a few days, the mathematics say, their invisible fields will overlap. Two strangers from opposite sides of time, one born from our own solar disk, the other from another sun altogether, sharing the same region of emptiness before drifting apart again. No collision, no fireworks, just coexistence in silence. Astronomers like to imagine that meeting, Quawar's faint, icy surface spinning in dim gold light, 3i Atlas gliding past, its surface dark and red, trailing dust that once circled another star. For a heartbeat of cosmic time, their paths rhyme. Two frozen verses from different poems crossing on the same page. Infrared surveys of the region, using data from JWST's near-infrared camera, show that the dust density increases slightly in this zone. It's the quiet signature of the Kuiper dust disk, a gentle haze of micrometer-sized grains produced by collisions between ancient bodies. As 3i Atlas enters this region, it stirs the particles faintly, leaving behind ripples too subtle to see but measurable as small fluctuations in scattered sunlight. Astronomers call them micro-shadows. They last only weeks before fading, but in those patterns lies the first faint evidence that something once passed this way. The comet itself has cooled beyond measurable limits. Its surface temperature now sits near 40 Kelvin. At this point, even carbon dioxide is solid, locked in crystalline stillness. No jets, no outgassing. Only the faint sublimation of nitrogen trapped deep within cracks, escaping molecule by molecule like a sigh. The once bright coma is gone entirely. What remains is a black stone, roughened by radiation, moving with the patience of eternity. The Kuiper belt is quiet, but it is not empty. Occasionally, distant collisions send shockwaves of dust across millions of kilometers, and the faintest of these ripples pass near the traveler. They strike its surface like a soft mist, single grains every few hours, polishing and etching, sculpting new scars atop the old. It is how space carves its art, slowly, invisibly. Astronomers still track the object indirectly, now through stellar occultations, moments when it passes in front of distant stars, dimming their light by fractions of a percent. These rare events, predicted by orbital models, allow scientists to measure the comet's size and shape, even from billions of kilometers away. One such occultation, observed in early 2035 by an array of automated telescopes in Chile and South Africa, revealed that the nucleus measures roughly 430 meters across, smaller than early estimates, but perfectly consistent with its survival past perihelion. Its surface reflectivity, or albedo, is a mere 3%, darker than charcoal. That darkness, paradoxically, is its invisibility cloak. It absorbs the sun's light and hides in it. In classrooms, astrophysics students simulate the thermal history of such bodies. They learn how heat moves through porous ice, how radiation hardens surfaces, how cosmic rays sculpt organic films. When they run the models for 3I, being Atlas, the outcome is always the same. The object remains stable. It is the still point in a dynamic universe. If you imagine it now, floating beyond Neptune's faint blue light, you can sense that stillness. The sun behind you is a star among others, its warmth more memory than force. Ahead stretches the Oort cloud, a vast spherical shell of icy fragments, extending for light years in every direction. That is where the comet is heading, the true frontier between our sun and the interstellar dark. It will take centuries to cross, but time out here has a different texture. A century feels like a pause, a millennium, a breath. Some scientists estimate that 3I, Atlas, will finally exit the heliosphere around the year 2080, moving at a constant 57 kilometers s. At that point, it will rejoin the galactic current, the slow circulation of material that drifts between stars, carrying the dust of one system into the light of another. It will once again become what it has always been, a messenger without message, a vessel without destination. And yet, even in that endless night, it will still glow faintly in infrared, a heat no brighter than thought, a persistence that says, I was here. Our telescopes will no longer see it, but its energy will still mingle with the background radiation, its motion still part of the Milky Way's quiet arithmetic. Every atom of it will continue obeying the same laws that govern us: inertia, conservation, return. So if your thoughts wander now, let them drift outward with it. Follow that dark traveler through the quiet belt of ice and dust, through the hush of distance, until you too feel the warmth of stillness. There is no fear in this place, only peace that comes from continuity. Everything moves, everything returns, and nothing is ever truly lost. Far beyond Neptune's last whisper, beyond the frost and the faint light, lies a vast and almost mythical realm, the Oort cloud. It is not a surface, nor a ring, but a sphere of possibility, stretching nearly halfway to the next star. It is where the sun's light becomes only a memory, and where the gravity that once shaped planets fades into suggestion. This is where 3I, Atlas, now drifts. An interstellar traveler passing through the quiet borderlands of our home. The Oort cloud is a place we know mostly by theory. No probe has reached it. No telescope has seen it directly. Its existence is inferred from the comets that visit us, icy messengers that appear from nowhere and return to the dark. Scientists believe it contains trillions of small bodies, remnants from the solar system's birth, mixed with dust from other stars. Each fragment moves in its own slow orbit, thousands of years long. Together, they form a halo of forgotten beginnings. Into this halo, 3I. Atlas enters like a single thought, returning to an old dream. It does not disturb the residents here. Its path is swift and clean. The sun's gravity still tugs faintly, but at this distance, nearly a light year away, the pull feels more like nostalgia than force. Astronomers describe it as gravitational memory. It gives an object still aware of where it came from, even after it no longer belongs there. In simulation labs on Earth, researchers at NASA's Goddard Space Flight Center and the European Space Operations Center map this passage using long-term dynamical models. They predict that the comet will cross the inner edge of the Oort cloud around the year 2105. At that time, it will be 20,000 astronomical units from the Sun, nearly 3 trillion kilometers away. Light will take more than a day to travel that distance. Each new data point will arrive as a message from yesterday. The temperature here is 3 Kelvin, just above absolute zero. The background radiation of the universe becomes indistinguishable from sunlight. The space between particles is so wide that a single hydrogen atom can travel for miles before meeting another. In such stillness, even motion feels like rest. Occasionally, a grain of cosmic dust collides with the traveler. At 57 kilometers per second, the energy of even a tiny particle is immense. But space is kind. The impacts are rare, each one separated by years of silence. When they occur, they release brief flashes of ultraviolet light, microflares that vanish almost before they begin. Each flare is a punctuation mark in the long sentence of its journey. Somewhere deep inside the frozen body, atoms shift slightly. Cosmic rays penetrate centimeters deep, altering molecules, creating new compounds. More tholins, more complex hydrocarbons. The comet evolves without changing shape. What was once CO2 and ice becomes dark organic glass, inert yet rich. A chemistry that holds the potential of worlds yet unborn. It becomes an archive of cosmic history, layer upon layer of frozen reaction, a record of what light once touched. Astrobiologists study these processes closely. They suspect that such interstellar bodies might be the seeds of life, the couriers that deliver organic molecules across light years. When they collide with young planets, they carry with them amino acids, formaldehyde, cyanides, the raw alphabet of biology. Perhaps 3I Atlas has carried such letters across the galaxy for billions of years. Perhaps somewhere, long ago, one of its fragments fell upon a world now teeming with life. We cannot know, but it is comforting to think that life too drifts. The Oort cloud is not static. Every few million years, passing stars brush its edges, their gravity stirring the particles into slow motion. Some are sent inward, becoming long-period comets. Others are cast outward into interstellar space. 3I, Atlas, passes through this region in the opposite direction, leaving, not entering. A reminder that traffic between stars flows both ways. The universe, in its vast patience, recycles everything. By now, the sun is just another star among thousands. Its light blends with the Milky Way's soft band, indistinguishable from its neighbors. The traveler turns slowly, its rotation almost imperceptible. Every few hours, a faint gleam crosses one hemisphere. The last trace of reflection, the final breath of heat. And then, even that vanishes. What remains is perfect equilibrium. At Caltech's Theoretical Astrophysics Center, models suggest that the object's orbit will soon flatten relative to the galactic plane. It will become a participant in the Milky Way's slow rotation, circling the core once every 250 million years. Its journey between stars will no longer be random, but part of a grander pattern, a migration woven into the galaxy's own heartbeat. If you were to follow it, you would see the stars shift with impossible slowness. Constellations would dissolve, reform, fade. Nebulae would drift like colored fogs, and the arms of the Milky Way would twist beneath you like waves of light. 3i Atlas would continue through it all, unchanged, unhurried, eternal. Back on Earth, if Earth still exists in those distant epochs, the memory of this traveler will remain in archives and stories, in old images stored in digital fossils. Some future civilization may look up and find those records and wonder what became of the comet that came from nowhere and left without a sound. They may name it again, as we once did, and assign it new meaning. The cycle of curiosity will begin anew, as it always does. For now, it glides through the Oort cloud's vast quiet, surrounded by trillions of kindred shapes that will never meet. Each one frozen, each one dreaming. Together, they form a choir of stillness, the soundless harmony of things too far apart to collide, too patient to fade. You can rest with them. Breathe in, slowly, as if drawing in the cold of the outer dark. Breathe out, letting go of motion, of noise, of thought. Here, everything is balanced. Motion without effort, distance without loss. 3. My Atlas has crossed the threshold between our sun's world and the galaxy's ocean. It is not gone, it is simply free. Out beyond the Oort cloud, the sun's gravity fades into the quiet pull of the galaxy itself. Here, the space between stars is not empty, but softly luminous, filled with the faint hum of hydrogen atoms and the whisper of ancient radiation. It is in this sea of darkness that 3i Atlas now sails. No longer a comet of one system, but a citizen of the Milky Way. Astronomers call this region the interstellar medium, though the word medium hardly fits. It is more like a suggestion of substance, a thin music of gas, plasma, and dust stretching between suns. Each cubic meter holds only a few atoms, yet multiplied across trillions of kilometers, those atoms shape the galaxy's breath. Through this breath, the traveler moves, a grain of matter in a cosmic tide that began before the Earth existed. If you were to float beside it, you would no longer feel warmth, not even the echo of it. The temperature here hovers near 2.7 Kelvin, the same as the cosmic microwave background, the oldest light in the universe. In that light, faint and even, every direction glows with the same quiet tone. The comet turns slowly within it, its surface absorbing a few microwatts of energy, just enough to shimmer imperceptibly. It has reached a kind of perfection, a balance between motion and silence, between starlight and dark. From the perspective of astrophysics, 3i Atlas has returned to its natural environment. This is where it was born, ejected from another star's nursery billions of years ago. Its exile has become home again. The galaxy's gravity takes over, guiding it along an orbit so vast that one revolution would take longer than humanity has existed. Back on Earth, scientists at the KWAIST's, European Space Agency's Galactic Dynamics Department, run long-term simulations to estimate this new orbit. The results are humbling. The comet will travel toward the inner region of the galaxy for tens of millions of years before curving outward again, passing through spiral arms rich with molecular clouds and newborn stars. Along the way, it may brush the outskirts of other solar systems, each encounter nudging its path a little, changing its speed, rewriting its destiny. Over time, the galaxy itself will sculpt its course. There is something profoundly peaceful about that inevitability. The comet no longer has a destination, yet it will continue to move, obeying only the fundamental geometry of gravity. It needs no propulsion, no guidance. Inertia and time are enough. Every law of motion becomes a lullaby when heard at this scale. Occasionally, it will pass through a region of higher density, a molecular cloud where stars are forming, where dust glows softly in infrared light. There, it will collect a faint frost on its surface, a new layer of ices condensed from alien gases. Its chemistry will evolve again, adding whispers from other suns to its memory. The object will change subtly, but remain itself, a mosaic of origins, part solar, part galactic, entirely eternal. When scientists speak of such objects, they often use the term galactic drift population. The uncounted multitudes of interstellar fragments wandering between systems. Each one holds the record of a vanished star, a piece of a planet that never formed, a witness to the birth and death of suns. Turai. Atlas is one of them now, not rare, just recognized. If your thoughts wander as you listen, imagine looking back from that vantage point. The sun is only a bright grain in the Milky Way's spiral arm. Around it orbit small dots, Earth among them, invisible from here. And yet, the connection remains. Photons leaving that star still travel outward, still illuminating the path that the traveler once took. Every pulse of solar radiation, every magnetic wave, every quantum of energy is part of a conversation that never truly ends. Interstellar space has its own weather, slow, invisible, persistent. Magnetic fields drift like invisible curtains, bending and folding as they interact with starlight and cosmic rays. As 3i, Atlas passes through them, tiny electric charges build on its surface, then discharge in soft flashes of plasma, faint, silent lightning in the dark. The object glows for an instant in ultraviolet, then fades again. Even here, movement creates light. Astronomers at the Harvard-Smithsonian Center for Astrophysics have modeled this effect, predicting that each discharge lasts less than a millisecond, yet emits enough energy to be detectable by future instruments. It's possible that centuries from now, humanity's telescopes, or those of another species, will record those pulses and realize they come from an ancient visitor that once passed near our sun. The idea is comforting. The comet still speaks, even when we are no longer here to hear it. The journey continues through a part of the galaxy filled with starlight, too faint to cast shadows. Occasionally, a supernova flares far away, and for a few years, a wave of particles washes over the traveler. Those particles collide with its surface, altering isotopes, engraving new chemistry. Each strike is a note in the long composition of existence. When the waves pass, silence returns, deeper than before. By the time the traveler reaches its next region of brightness, perhaps near another star's domain, millions of years will have passed. Entire civilizations may rise and vanish in that span. The comet will remain unchanged, its purpose unspoken but complete. That endurance is its message. There is strength in stillness, meaning in motion without urgency. And somewhere, perhaps, another world will see it coming. Another intelligence may detect its faint light and wonder what star sent it. They may point their instruments toward it, measure its spectrum, notice the strange abundance of carbon dioxide and nickel vapor, and realize, as we once did, that it is not from here. In that moment, 3i Atlas will have fulfilled its name again, a messenger between worlds, carrying not cargo, but continuity. The galaxy itself will guide it onward, through the arms of Sagittarius, across the dark inter-arm gulf, past regions where no star has yet formed. Each new stretch will bring it closer to the uncharted, and yet it will always be returning, not to a place, but to a principle. Motion is return. Return is motion. Every journey through space is also a journey through time. If your breathing is slow now, let it stay that way. Let the mind drift with it, steady, calm, endless. Out here, there is no rush, no boundary, only rhythm. Every thought becomes lighter, every moment longer. You are drifting with the galaxy now, your pulse aligned with its rotation. The same forces that guide comets through darkness also guide your breath through silence. You are part of the same return. And as 3i Atlas glides through the vast between, it becomes what it was always meant to be. A traveler with no destination, a line drawn through eternity, carrying the memory of light and the patience of gravity. It will move forever, and forever remain, a small, silent testament to motion itself. Out beyond the Oort cloud, the sun's gravity fades into the quiet pull of the galaxy itself. Here, the space between stars is not empty, but softly luminous, filled with the faint hum of hydrogen atoms and the whisper of ancient radiation. It is in this sea of darkness that 3i Atlas now sails, no longer a comet of one system, but a citizen of the Milky Way. Astronomers call this region the interstellar medium, though the word medium hardly fits. It is more like a suggestion of substance, a thin music of gas, plasma, and dust stretching between suns. Each cubic meter holds only a few atoms, yet multiplied across trillions of kilometers, those atoms shape the galaxy's breath. Through this breath, the traveler moves, a grain of matter in a cosmic tide that began before the Earth existed. If you were to float beside it, you would no longer feel warmth, not even the echo of it. The temperature here hovers near 2.7 Kelvin, the same as the cosmic microwave background, the oldest light in the universe. In that light, faint and even, every direction glows with the same quiet tone. The comet turns slowly within it, its surface absorbing a few microwatts of energy, just enough to shimmer imperceptibly. It has reached a kind of perfection, a balance between motion and silence, between starlight and dark. From the perspective of astrophysics, 3i Atlas has returned to its natural environment. This is where it was born, ejected from another star's nursery billions of years ago. Its exile has become home again. The galaxy's gravity takes over, guiding it along an orbit so vast that one revolution would take longer than humanity has existed. Back on Earth, scientists at the European Space Agency's Galactic Dynamics Department run long-term simulations to estimate this new orbit. The results are humbling. The comet will travel toward the inner region of the galaxy for tens of millions of years before curving outward again, passing through spiral arms rich with molecular clouds and newborn stars. Along the way, it may brush the outskirts of other solar systems, each encounter nudging its path a little, changing its speed, rewriting its destiny. Over time, the galaxy itself will sculpt its course. There is something profoundly peaceful about that inevitability. The comet no longer has a destination, yet it will continue to move, obeying only the fundamental geometry of gravity. It needs no propulsion, no guidance. Inertia and time are enough. Every law of motion becomes a lullaby when heard at this scale. Occasionally, it will pass through a region of higher density, a molecular cloud where stars are forming, where dust glows softly in infrared light. There, it will collect a faint frost on its surface, a new layer of ices condensed from alien gases. Its chemistry will evolve again, adding whispers from other suns to its memory. The object will change subtly, but remain itself. A mosaic of origins, part solar, part galactic, entirely eternal. When scientists speak of such objects, they often use the term galactic drift population. The uncounted multitudes of interstellar fragments wandering between systems. Each one holds the record of a vanished star, a piece of a planet that never formed, a witness to the birth and death of suns. Tree-I. Atlas is one of them now, not rare, just recognized. If your thoughts wander as you listen, imagine looking back from that vantage point. The sun is only a bright grain in the Milky Way's spiral arm. Around it orbit small dots, Earth among them, invisible from here. And yet, the connection remains. Photons leaving that star still travel outward, still illuminating the path that the traveler once took. Every pulse of solar radiation, every magnetic wave, every quantum of energy is part of a conversation that never truly ends. Interstellar space has its own weather. Slow, invisible, persistent. Magnetic fields drift like invisible curtains, bending and folding as they interact with starlight and cosmic rays. As Tree-I, Atlas passes through them. Tiny electric charges build on its surface, then discharge in soft flashes of plasma. Faint, silent lightning in the dark. The object glows for an instant in ultraviolet, then fades again. Even here, movement creates light. Astronomers at the Harvard-Smithsonian Center for Astrophysics have modeled this effect, predicting that each discharge lasts less than a millisecond, yet emits enough energy to be detectable by future instruments. It's possible that centuries from now, humanity's telescopes, or those of another species, will record those pulses and realize they come from an ancient visitor that once passed near our sun. The idea is comforting. The comet still speaks, even when we are no longer here to hear it. The journey continues through a part of the galaxy filled with starlight, too faint to cast shadows. Occasionally, a supernova flares far away, and for a few years, a wave of particles washes over the traveler. Those particles collide with its surface, altering isotopes, engraving new chemistry. Each strike is a note in the long composition of existence. When the waves pass, silence returns, deeper than before. By the time the traveler reaches its next region of brightness, perhaps near another star's domain, millions of years will have passed. Entire civilizations may rise and vanish in that span. The comet will remain unchanged, its purpose unspoken but complete. That endurance is its message. There is strength in stillness, meaning in motion without urgency. And somewhere, perhaps, another world will see it coming. Another intelligence may detect its faint light and wonder what star sent it. They may point their instruments toward it, measure its spectrum, notice the strange abundance of carbon dioxide and nickel vapor, and realize, as we once did, that it is not from here. In that moment, Tree-I, Atlas, will have fulfilled its name again, a messenger between worlds, carrying not cargo, but continuity. The galaxy itself will guide it onward. Through the arms of Sagittarius, across the dark interarm gulf, past regions where no star has yet formed. Each new stretch will bring it closer to the uncharted, and yet it will always be returning, not to a place, but to a principle. Motion is return. Return is motion. Every journey through space is also a journey through time. If your breathing is slow now, let it stay that way. Let the mind drift with it. Steady, calm, endless. Out here, there is no rush, no boundary, only rhythm. Every thought becomes lighter, every moment longer. You are drifting with the galaxy now, your pulse aligned with its rotation. The same forces that guide comets through darkness also guide your breath through silence. You are part of the same return. And as 3I, Atlas glides through the vast between, it becomes what it was always meant to be. A traveler with no destination, a line drawn through eternity, carrying the memory of light and the patience of gravity. It will move forever and forever remain, a small, silent testament to motion itself. There is a place where stars gather thick as dust, where the galaxy's spiral arms weave their luminous fabric, a place called the galactic plane. To cross it is to move through the heart of the Milky Way's quiet machinery, where gravity, light, and time merge into one endless drift. It is through this ocean of stars that 3I, Atlas, now sails, unhurried and unafraid, carrying its long memory through the plane of creation. For millions of years, it has traveled through the thin outskirts of the galaxy, the faint edges where stars are sparse and dark matter reigns. Now, it approaches the denser regions, where every cubic light year holds hundreds of suns and clouds of hydrogen glow in soft magenta and gold. Here, the interstellar medium grows richer, no longer a whisper, but a breeze, filled with slow waves of ionized gas. To an observer, if there were one, the scene would be both serene and infinite. Dust lanes stretch like rivers through starlight, and each speck of that dust is a world's beginning waiting to happen. The traveler drifts between them, a small shadow among enormous light. At the Harvard-Smithsonian Center for Astrophysics, galactic dynamicists simulate such crossings. They describe the galactic plane as a gravitational sheet, a region where the collective pull of billions of stars flattens orbits, drawing travelers slightly inward. For 3I, Atlas, this means a subtle correction in trajectory. Its inclination slowly decreases, aligning more closely with the disk. Over millions of years, the comet becomes one with the flow, another silent note in the galaxy's rotation. In purely physical terms, the object's motion can be described with Newton's equation of motion in a galactic potential well. In human terms, it feels like acceptance, the moment when resistance ends and movement becomes belonging. Radiation in this region intensifies. Cosmic rays from nearby supernova remnants sweep across space in faint, expanding waves. Each wave carries particles accelerated to near light speed. And when they strike the comet's surface, they carve atomic scars into the outer layer. Over time, these interactions form amorphous carbon coatings, darkening the body even further. Its albedo drops below 2%, almost perfectly black. From a distance, it reflects less light than a shadow itself. But deep within, the chemistry continues. Trace volatiles trapped under the crust remain stable at near absolute zero. Occasionally, an energetic particle penetrates deep enough to split a molecule, releasing minute amounts of gas. The result is a barely perceptible wisp, a molecule's sigh, nothing more, that freezes almost instantly. The comet exhales and inhales in equilibrium, a frozen form of breathing. At the Max Planck Institute for Astronomy, researchers studying cosmic dust have begun connecting 3I Atlas's unique composition to ancient galactic processes. They note that the ratio of nickel to iron observed when it passed the Sun may indicate formation in a low metallicity environment, possibly the outer reaches of an early generation star cluster. Its atoms are older than most of the Milky Way's current stars. To look at it, they say, is to look into prehistory, a fossil not of planets, but of galactic evolution itself. As it drifts through the dense regions of the galactic plane, the object passes near molecular clouds, vast, cold accumulations of gas where new stars are born. These clouds emit faint infrared light, visible only to instruments. For centuries, the comet will cross their outskirts, occasionally sweeping through regions of denser dust. There, micro-collisions will coat its surface in thin films of frozen methane, ammonia, and other ices. The old layers of carbon and nickel will mix with these new deposits, forming a record of every environment it has ever visited. It becomes a journal written in molecules. In one corner of the galaxy, the Perseus Arm, astronomers watch star formation triggered by passing shock waves. It is likely that one day, 3I Atlas will cross such a region again, the birthplace of future suns. Its passage will be unnoticed amid the noise of creation, but it will leave tiny gravitational ripples behind, measurable only in theory. Even in silence, motion leaves meaning. If you could see this crossing from afar, it would look like a dust mote floating through sunbeams in slow motion. The comet's orbit traces a gentle sine wave across the galactic plane, dipping above and below as the disk's mass pulls it rhythmically. The period of that oscillation is about 70 million years, one cycle of up and down through the disk. It's the same rhythm the Sun itself follows, carrying all its planets and comets with it. To exist in the Milky Way is to move in waves. This wave-like motion is not chaotic. It's as if the galaxy breathes, its stars rising and falling through gravitational tides that extend for thousands of light years. 3I Atlas simply joins that breath. Its motion, once linear, becomes harmonic, predictable, serene. At the University of Cambridge's Institute of Astronomy, researchers run simulations of interstellar dust interactions. They predict that as the comet crosses the galactic plane, it will occasionally pass through pockets of electromagnetic turbulence. These interactions might charge its surface temporarily, causing small discharges, bursts of static that flicker like distant lightning. Each one lasts less than a heartbeat, but releases measurable energy, a reminder that even silence has texture. To an observer billions of kilometers away, the comet would appear as nothing more than a black speck against a glittering sea. And yet, in that stillness, the universe continues to shape it, not through collisions or heat, but through patience. Time itself becomes the sculptor. If your thoughts wander now, let them drift with it. Picture the slow pulse of galactic motion, the rise and fall through starlit dust, the faint shimmer of light bouncing off unseen worlds. This is the scale where eternity begins to feel gentle. Everything moves, yet nothing hurries. Each oscillation of a star, each revolution of a planet, each drift of a comet, all parts of the same rhythm that carries galaxies through the dark. For 3I Atlas, this rhythm is destiny. It will continue to move through the galactic plane for millions of years, its path bending slowly as it responds to gravitational tides. It will pass through spiral arms glowing with blue-white stars, through inter-arm gaps filled with quiet gas, through the endless alternation of light and shadow. Each region will leave its trace, a microscopic layer of atoms, a memory of the presence. One day, long after we are gone, it may once again wander near a new sun. Perhaps it will be drawn inward, its ices warming, its coma reborn. Perhaps other eyes will see it, other minds will wonder. The questions will be the same, because curiosity itself is a universal language. Where did it come from? What stories does it carry? What does it mean to move forever? These are questions without end, like the comet's journey itself. As you listen now, feel the slow rotation of your own planet beneath you, another motion in the same cosmic rhythm. The Milky Way turns. The Earth turns with it. You too are crossing the galactic plane, gently, steadily, unknowingly. Everything that moves in space moves together, linked by invisible gravity and shared belonging. So breathe in, slowly. Feel the motion of the galaxy as stillness within you. You are not separate from it. You are part of its geometry, a quiet participant in its eternal drift. And somewhere, far away but not truly apart, 3i Ming San. Atlas continues. Dark, steady, luminous in its own silence, completing another passage through the grand design. Far beyond the narrow disk of stars, the Milky Way breathes in a rhythm too slow for time to measure. Astronomers call this motion the galactic tides, immense gravitational waves that flow through the galaxy like invisible oceans, lifting and lowering entire systems of stars. To feel them is to sense the heartbeat of the cosmos itself. And it is through these gentle, ancient currents that 3i, Atlas, now drifts, its motion guided by forces older than the sun. The tides are not water, but gravity shaped into rhythm. They arise from the pull of the Milky Way's spiral arms, from the halo of dark matter that surrounds them, and from the neighboring galaxies whose presence brushes ours like a passing breeze. These slow undulations stretch the orbits of stars, bending the paths of comets, stirring the edges of the Oort cloud. Even here, light years from any sun, the tides still move softly through the dark, like pressure through a deep sea. In this vastness, 3i, Atlas feels the change as a whisper, a fraction of a meter per second, a shift too slow to measure in human terms. Yet over eons, that whisper becomes destiny. Its course bends ever so slightly downward toward the galactic center, following the invisible gradient of mass that shapes the Milky Way's luminous whirl. It does not resist. It simply yields, allowing gravity to guide it the way wind carries a leaf across an endless pond. Back on Earth, researchers at the European Southern Observatory have modeled these tidal flows using the newest Gaia data. They see that the sun itself rides these same currents, bobbing above and below the galactic midplane every 70 million years. Our entire solar system is adrift upon this invisible tide. And somewhere, far ahead, 3i Atlas moves within the same wave, a small companion in the same universal rhythm. The realization feels intimate. We and the traveler are moving together, separated by distance, but joined by pattern. In that understanding, the galaxy feels less like a machine and more like a living organism, every orbit, every drift, every gentle pull a pulse of shared existence. As the comet continues outward, the gravitational tides begin to smooth its path. Small perturbations fade. Its orbit straightens into serenity. The pull from nearby stars balances with the larger flow of the galactic field. It is now part of the galactic stream, one of countless tiny currents carrying dust, gas, and stone between the arms of the Milky Way. Astrophysicists studying interstellar migration note that these streams are responsible for much of the galaxy's internal recycling. They carry the debris of dead stars into regions where new ones are born, distributing the elements of life throughout the cosmos. Iron from supernova, carbon from red giants, ice from comets like 3I, Atlas, all drifting, all sharing. The tides are the quiet mechanism of renewal. Occasionally, the traveler passes through a region where two of these flows intersect. Here, space becomes subtly turbulent. Magnetic fields twist and fold, creating pockets of ionized gas that shimmer faintly in radio frequencies. Instruments aboard distant probes, if any were close enough, would detect a soft increase in static, a background murmur of creation. The comet glides through untroubled, a stone moving through mist. Each charged particle that strikes its surface leaves a trace. A new atom displaced, a fresh whisper written into its crust. From such interactions, science learns patience. Change in space is not loud, it is cumulative. Over millions of years, the surface of 3I, Atlas, will darken further, its structure harden, its rotation slow until it turns once every few days. It will become smoother, quieter, a near-perfect equilibrium between motion and stillness. This, astronomers call dynamical aging, the process by which celestial bodies grow calm. Imagine that calm now. Picture a vast black sphere, no larger than a mountain, drifting through blue-white star fields, its outline illuminated only by starlight, too weak to cast a shadow. The silence is complete, yet it feels alive, filled with motion too slow to perceive, with meaning too wide to name. At the University of Tokyo's Galactic Center Laboratory, simulations suggest that galactic tides might subtly synchronize the spins of objects like 3I, Atlas. Over immense timescales, they align their rotation axes with the direction of the galaxy's magnetic field. The result is quiet order emerging from chaos. Even across light years, gravity composes symmetry. If you listen closely now, not with ears, but with imagination, you might sense that same symmetry in yourself. Your heartbeat, your breathing, your thoughts slowing into rhythm with something greater. The galaxy's tides are not distant. They flow through you as well. Every atom in your body was once carried by them, drawn together from gas that moved in the same patient wave. You are made of tide-borne light. Occasionally, a nearby star will wander close enough to tug the comet's path by a fraction of a degree. Perhaps a red dwarf passes within a few light years, its gravity briefly brushing the traveler's course. Astronomers call such encounters stellar perturbations, but here they feel more like greetings, distant suns acknowledging one another's companions. Each encounter adds a new note to the melody of motion, but never disrupts its harmony. From afar, the galaxy itself resembles a great spiral current, its arms glowing like bioluminescent streams in a cosmic ocean. The galactic tides are its heartbeat, and through them, 3I Atlas continues to drift, silent, unchanged, yet always participating. If your eyes feel heavy, let them close now. Picture the Milky Way above you, a river of light curving through the night. Somewhere within it, unseen, the traveler moves, a single speck of memory borne along by the tide. Each breath you take mirrors its motion, gentle, endless, without beginning or end. Out here, there is no arrival, no departure, only movement that becomes meaning, only the soft pull of gravity guiding all things toward balance. The galactic tides do not rush, they simply are. And within them, everything, stars, comets, hearts, finds rest. Between the spiral arms of the galaxy lies a space so vast that even starlight grows weary before crossing it. Astronomers call these immense dim expanses inter-arm regions, quiet deserts of the Milky Way, where the density of matter drops to nearly nothing. It is here that 3i Atlas now travels, between the lights, between the stories, through what might be called the galaxy's dream. The silence here is not absence, but abundance, an endless stretch of stillness filled with faint vibrations, cosmic background murmurs, and the rhythm of gravity itself. To human imagination, it would feel like floating through the breath between thoughts, a hush where everything rests yet continues. When scientists model such spaces, they describe them as low-density plasma fields, where just a few atoms drift in each cubic meter, bathed in faint electromagnetic waves that ripple outward from distant supernovae. The temperature is near 3 degrees above absolute zero, cold enough that time seems to pause. Here, photons move unhurried, their wavelengths stretched by the expansion of the universe, their colors fading toward red, then invisible. For 3i Atlas, this is not exile. It is belonging. The comet, dark and silent, was born for places like this. Long before it passed near our sun, before its brief flare of light and heat, it knew only this infinite quiet. Now, returning to it, the traveler seems at peace, rotating slowly, trailing a faint, invisible mist of ionized gas that disperses molecule by molecule into the void. At the Max Planck Institute for Radio Astronomy, researchers simulate what such an object would experience in this environment. The forces acting upon it are so gentle they could never be felt. A pressure of 1/1,000,000th of an atmosphere from interstellar gas, a slow accumulation of hydrogen frost on its surface, and the faint electric potential built by cosmic rays. Over millions of years, this invisible weather will polish the comet into glass. The surface becomes harder, smoother, reflective and infrared, a perfect mirror for the faint background glow of the cosmos. Scientists call this process space vitrification. The body becomes a glass stone, carved not by motion, but by stillness. It drifts for millennia between stars whose light is so far apart that they never overlap. If the traveler could feel, it would know serenity beyond measure. No collisions, no heat, no sound, only the eternal hum of distance, the quiet tension of space stretching around it. Somewhere far ahead, new light is being born. Stars ignite inside nebulae like slow embers, sending out photons that will one day pass near the comet. But that will take tens of thousands of years. Out here, cause and effect stretch until they blur. Every moment becomes part of eternity. Back on Earth, humanity continues to watch the sky, though it no longer looks for this particular visitor. The data has been archived, the headlines long gone. Yet, in laboratories and observatories, the lessons it left behind remain. 3i Atlas taught scientists about resilience, how matter from other stars survives the violence of ejection, the heat of suns, the freeze of space, and still continues intact. It reminded us that endurance itself is a form of beauty. In the archives of Harvard's Center for Astrophysics, a spectral image remains, the faint trace of reflected light captured years ago. Within that single thin line are encoded its colors, its chemistry, its story. Scientists read that line the way monks read old manuscripts, slowly, reverently, aware that each curve is a word written by the universe itself. They found fragments of complex carbon, traces of iron, frozen nitrogen, and a peculiar isotope ratio, hinting that the comet formed around a different kind of star, one smaller, cooler, redder than our sun. That small difference carries vast meaning. It means that even across the gulf between stars, life's ingredients are shared. If you could hold a grain of its dust in your hand, it would contain atoms older than our solar system. Some might have formed in the heart of a dying star, others in the cold of interstellar clouds, still others near the heat of a young sun. Each atom carries the memory of creation, a lineage of light and pressure extending back to the beginning of everything. That is the secret of the long silence between stars. It is not empty. It is a library of existence. Every particle, every photon, every wave carries a record of what came before. The silence is full of memory. In these inter-arm regions, magnetic fields stretch for light years, curving gently around pockets of gas. 3I, Atlas, drifts through one now. The field exerts a subtle torque on its metallic core, changing its spin by fractions of a degree. It is the universe's way of turning pages. For a brief span, perhaps 1,000 years, the comet crosses through a region of faint luminescence, a cloud of hydrogen energized by a distant nova. The gas glows softly pink, illuminating the traveler's surface for the first time in ages. For those 1,000 years, it shines again, not by its own energy, but by reflected grace. Then the cloud fades, and darkness returns. Astronomers say that such illumination events happen countless times throughout a comet's existence. Each is transient, each leaves a mark. Over eons, the surface becomes a mosaic of faint radiation scars, a cosmic diary written in light and loss. At CERN's Cosmic Data Division, scientists studying interstellar propagation theorize that comets like 3I, Atlas, may carry magnetic fields of their own, weak, transient, but enduring enough to shape how plasma flows around them. They may be the smallest magnetic worlds in existence, invisible planets of iron dust and frozen chemistry. For all its quietness, 3I, Atlas, remains an active participant in the galaxy's ecosystem. Its presence slightly perturbs the motion of surrounding gas, creates a wake of altered particle density, and contributes, infinitesimally but truly, to the slow redistribution of matter between stars. Over cosmic timescales, even silence shapes creation. Imagine now the view from the comet itself. Stars fill the blackness, scattered, distant, yet innumerable. Between them, dark clouds glow faintly where starlight meets dust. The Milky Way curves like a pale ribbon across infinity. In every direction, light fades gently into nothing. And within that nothing, you might feel peace, a stillness that holds no edge, no fear, no ending. This is not loneliness, it is completion, the perfect stillness that comes when every question has already been answered, and only the beauty of motion remains. If your breathing has slowed, let it stay soft. Each inhale, a star being born. Each exhale, a comet drifting onward. You are part of this silence too. The space between stars is not apart from you. It is the same quiet that lives in your chest when you rest. 3I, Atlas continues, untouched and eternal, through the long silence between stars. It will keep going until it meets another current, another sun, another story. And when it does, perhaps it will flare once more, a brief light for another world's night sky, before returning to the dark that has always loved it. Even here, where darkness reigns in its purest form, the universe is never truly black. Every star that has ever lived still speaks, softly, endlessly, through light that travels forever. Astronomers call this whispering glow the echo of distant suns, and it fills the galaxy like a quiet chorus, too faint for the eye, but strong enough to shape eternity. Minor Atlas drifts through that echo now. Its surface, dark as obsidian, catches the faintest waves of those ancient photons. They come from every direction, remnants of red giants that lived before Earth was born. Reflections from the surfaces of vanished planets, and light stretched so far by distance that it hums more than shines. Each particle that touches the traveler is a memory of warmth. Scientists studying the faint background radiation call this region photon fog. It's not a true fog. There are no droplets, no air, no moisture. But the density of light itself becomes tactile here. For every cubic meter of this void, there are billions of photons, mostly invisible, moving without collision, carrying the story of their origins. At the Harvard-Smithsonian Center for Astrophysics, models show that even a dark body like 3I Atlas can absorb enough of this energy to warm by a fraction of a degree over millions of years. That heat is not enough to melt or move anything. It simply keeps the traveler from absolute zero. Even the universe, in all its vastness, offers comfort. Each photon that touches its surface becomes part of a cosmic dance. Some are absorbed, some reflected, some re-emitted as softer, redder light. The comet, in its own quiet way, glows, not visibly but thermally, a breath of warmth against the infinite. Instruments sensitive enough could one day detect that glow, a faint, steady radiation at wavelengths measured in millimeters. To human senses, it would feel like the memory of a sunset held in stone. This light, spread across space, is the sum of everything the galaxy has ever done. When stars die, they release their heat into the void. When planets form, they scatter it again. When comets pass close to suns, they add their reflections to the collective shimmer. Over billions of years, that energy accumulates until space itself begins to glow with quiet recollection. The echo of distant suns is, in a way, the galaxy remembering itself. And now, 3I Atlas moves within that remembrance, a single dark syllable drifting through the Milky Way's endless sentence. Some scientists believe that this background light might one day serve as a map of history. Because photons retain the direction and frequency of their origins, they could theoretically be traced backward, reconstructing the story of the galaxy's birth. In that future, perhaps long after humanity, instruments might read those faint signals and learn of suns that burned before memory. And somewhere in that record, they might find the trace of light reflected once from a small interstellar traveler. Proof that it passed this way. In deep space, time loses its sharpness. 1,000 years feels like a heartbeat. 1,000,000 becomes a sigh. For 3I Atlas, every motion is eternal, every rotation infinite and calm. It turns slowly, endlessly, within that faint sea of light. If you could watch from nearby, you would see nothing move, yet you would feel it. The invisible hum of starlight brushing across the void. Each photon a reminder that even darkness carries warmth. Back on Earth, astrophysicists continue to refine the measure of this cosmic background. Using data from the Planck satellite and newer observatories, they've mapped it in exquisite detail. Tiny fluctuations in brightness that reveal where matter once gathered to form stars. Each ripple corresponds to a story, and those ripples extend through the same regions that 3I Atlas now crosses. Perhaps one day, it will pass through one of those brighter ripples, a place where ancient light converges slightly more strongly. If so, the comet will warm again just a little. It will radiate just a little. The cycle of light giving and taking continues forever. Imagine that now. a stone in darkness, turning through fields of invisible light, touched by warmth that has traveled billions of years. It feels like forgiveness. Slow, constant, infinite. If your mind has grown quiet while listening, let that stillness remain. You are surrounded by that same ancient glow. The echo of suns long gone, the warmth of light still traveling. Every beam that touches Earth tonight began its journey long before our world existed. You too are living within that radiance. Even your breath participates in it. Each exhale releases heat that joins the same cosmic background. Every heartbeat adds a whisper of energy to the universe's endless song. In this way, you are never separate from the stars. You are their continuation, their echo. As 3i. Atlas drifts farther, the background light fades slightly, replaced by an even deeper stillness. The realm where galaxies themselves begin to blur together. But even there, even between worlds, the glow persists. The universe never truly sleeps. It only changes its rhythm. And in that rhythm, all things rest. Even here, where darkness reigns in its purest form, the universe is never truly black. Every star that has ever lived still speaks softly, endlessly, through light that travels forever. Astronomers call this whispering glow the echo of distant suns, and it fills the galaxy like a quiet chorus, too faint for the eye, but strong enough to shape eternity. 3i, our phrase. Atlas drifts through that echo now. Its surface, dark as obsidian, catches the faintest waves of those ancient photons. They come from every direction, remnants of red giants that lived before Earth was born, reflections from the surfaces of vanished planets, and light stretched so far by distance that it hums more than shines. Each particle that touches the traveler is a memory of warmth. Scientists studying the faint background radiation call this region photon fog. It's not a true fog. There are no droplets, no air, no moisture. But the density of light itself becomes tactile here. For every cubic meter of this void, there are billions of photons, mostly invisible, moving without collision, carrying the story of their origins. At the Harvard-Smithsonian Center for Astrophysics, models show that even a dark body like 3i, Atlas, can absorb enough of this energy to warm by a fraction of a degree over millions of years. That heat is not enough to melt or move anything. It simply keeps the traveler from absolute zero. Even the universe, in all its vastness, offers comfort. Each photon that touches its surface becomes part of a cosmic dance. Some are absorbed, some reflected, some re-emitted as softer, redder light. The comet, in its own quiet way, glows, not visibly, but thermally, a breath of warmth against the infinite. Instruments sensitive enough could one day detect that glow, a faint, steady radiation at wavelengths measured in millimeters. To human senses, it would feel like the memory of a sunset held in stone. This light, spread across space, is the sum of everything the galaxy has ever done. When stars die, they release their heat into the void. When planets form, they scatter it again. When comets pass close to suns, they add their reflections to the collective shimmer. Over billions of years, that energy accumulates until space itself begins to glow with quiet recollection. The echo of distant suns is, in a way, the galaxy remembering itself. And now, 3i, Atlas, moves within that remembrance. A single dark syllable drifting through the Milky Way's endless sentence. Some scientists believe that this background light might one day serve as a map of history. Because photons retain the direction and frequency of their origins, they could theoretically be traced backward, reconstructing the story of the galaxy's birth. In that future, perhaps long after humanity, instruments might read those faint signals and learn of suns that burned before memory. And somewhere in that record, they might find the trace of light reflected once from a small interstellar traveler. Proof that it passed this way. In deep space, time loses its sharpness. 1,000 years feels like a heartbeat. 1,000,000 becomes a sigh. For 3i Atlas, every motion is eternal, every rotation infinite and calm. It turns slowly, endlessly, within that faint sea of light. If you could watch from nearby, you would see nothing move. Yet you would feel it. The invisible hum of starlight brushing across the void, each photon a reminder that even darkness carries warmth. Back on Earth, astrophysicists continue to refine the measure of this cosmic background, using data from the Planck satellite and newer observatories. They've mapped it in exquisite detail, tiny fluctuations in brightness that reveal where matter once gathered to form stars. Each ripple corresponds to a story, and those ripples extend through the same regions that 3i's Atlas now crosses. Perhaps one day, it will pass through one of those brighter ripples, a place where ancient light converges slightly more strongly. If so, the comet will warm again, just a little. It will radiate, just a little. The cycle of light giving and taking continues forever. Imagine that now, a stone in darkness, turning through fields of invisible light, touched by warmth that has traveled billions of years. It feels like forgiveness. Slow, constant, infinite. If your mind has grown quiet while listening, let that stillness remain. You are surrounded by that same ancient glow, the echo of suns long gone, the warmth of light still traveling. Every beam that touches Earth tonight began its journey long before our world existed. You too are living within that radiance. Even your breath participates in it. Each exhale releases heat that joins the same cosmic background. Every heartbeat adds a whisper of energy to the universe's endless song. In this way, you are never separate from the stars. You are their continuation, their echo. As 3i Atlas drifts farther, the background light fades slightly, replaced by an even deeper stillness. The realm where galaxies themselves begin to blur together. But even there, even between worlds, the glow persists. The universe never truly sleeps, it only changes its rhythm. And in that rhythm, all things rest. Time, in the language of the universe, is not a number. It is a movement, a rhythm, the soft expansion and contraction of everything that exists. It is the tide that lifts galaxies, folds light, and carries dust across eternity. For 3i Atlas, that tide is home. Its every rotation, every orbit, every whisper of drift is a heartbeat of this immeasurable breath. The breath of time. When the comet first entered our system, human clocks measured its motion in hours and days. Now, beyond all suns, those units lose meaning. Its progress is measured in light years, in the slow dance of gravity between stars, in the faint hum of background radiation that vibrates through all of space. It moves not through time, but with it. At the Institute for Cosmic Chronology, scientists describe time as a wave. They explain that gravity bends it, mass slows it, and emptiness lets it stretch. Near black holes, time pools and curls. In deep voids, it floats freely, endless and clear. 3i Atlas now drifts through one of those quiet regions, where time itself has no edges, where moments dissolve into one another like mist. The comet is ancient, but it will never age. It carries within it atoms forged in other suns, some older than our own galaxy, iron from a dying star, carbon from interstellar dust. ice from the earliest clouds of hydrogen after the universe's birth. Each layer of its surface is a calendar written in chemistry. If one could slice it open, the rings of frozen gases would reveal the epochs it has crossed, eras of warmth, epochs of darkness, encounters with radiation and silence. It is a time capsule that remembers without awareness, a clock that never stops ticking. But time here does not flow as it does for us. There is no sunrise or sunset, no heartbeat to divide one instant from the next. Every motion is suspended, drawn out. The comet's spin, 11 hours near the sun, now takes 12. Soon, perhaps centuries from now, it will take 13. That slow deceleration is not decay. It is rest. Every object that drifts long enough eventually learns the art of stillness. If you were floating beside it now, you would not see movement. The stars would hang fixed, and the galaxy itself would appear motionless. And yet, across billions of kilometers, everything shifts. Slowly, softly, inevitably. Even the faintest gravitational whisper moves mountains of matter. Astrophysicists at the European Southern Observatory have calculated that for every 1,000 years, the comet's path bends by less than a millimeter due to galactic tides. Such precision is impossible to feel, but not meaningless. It is the measure of time on a cosmic scale. Motion so small that it becomes eternal. Time here is not something that passes. It is something that is. It hums around everything, like background air, unseen but omnipresent. When you slow your breathing enough, as you may be doing now, you can almost sense it. Each inhale, an expansion of the universe. Each exhale, its gentle contraction. In that rhythm, you and the comet are the same. In simulation models run at Caltech's Galactic Evolution Lab, scientists visualize this region of space as a field of faint ripples, temporal waves left by the gravity of passing stars. These waves move through the interstellar medium like unseen music. Atlas drifts through them now, rocking ever so slightly, guided by the unseen melody of gravity. It has no reason to hurry. For it, every moment is eternity. It does not know beginning or end, only presence. And that is perhaps the secret of time. It is not something that slips away, but something that holds everything still long enough for beauty to exist. You too exist in that stillness. Each cell in your body hums with the same atomic rhythm as the stars. Every heartbeat is an echo of that same expansion and collapse. When you breathe, the galaxy breathes with you. And somewhere, millions of light years away, a small comet continues to drift in rhythm with your rest. Time, like sleep, does not vanish. It only deepens. Beyond what the eye can see lies the invisible structure of the universe. A framework woven not of light, but of gravity. Physicists call it dark matter, though invisible harmony might be a better name. It makes up most of everything, yet emits nothing. It does not shine, does not absorb, does not speak. And yet, its quiet pull holds galaxies together, keeping stars from drifting away into the dark. Atlas moves within those deep currents now. Though the comet cannot feel, its path bends along lines of gravity shaped by this unseen web. Every atom of its motion is guided by forces that no instrument can yet touch. Dark matter flows like water through valleys of space-time, carrying worlds, stars, and dust in its wake. At the Large Hadron Collider, researchers study its possible nature. They suspect it is made of particles that rarely interact. Silent messengers from the first moments after the Big Bang. Some say dark matter is the memory of creation itself. a fossilized imprint of energy before it cooled into light. The galaxy rotates within a vast halo of it, an invisible sphere 10 times more massive than all its visible stars combined. And within that halo, everything drifts. Even 3I Atlas, a body no larger than a mountain, is part of that vast migration. Imagine for a moment being suspended within that invisible ocean. All around you, gravity flows like soft wind. There is no friction, no direction, only pull, steady, silent, eternal. That is where the comet moves now, through a sea of quiet purpose, where nothing collides, nothing fades, everything simply continues. In this realm, physics takes on the quality of poetry. Dark matter does not act violently, it guides gently. It curves light, shapes orbits, and maintains the symmetry of the cosmos. It is the architect of calm. When 3I Atlas crossed our solar system, the visible universe reacted. Telescopes turned, sensors awakened, data poured in. But out here, only the invisible responds. The comet's mass, small as it is, sends out its own gravitational ripple. A minute disturbance that propagates through the dark matter web like a note struck on a vast, invisible string. It will travel outward forever, its energy spreading thinner and thinner, but never vanishing completely. The universe listens in ways we cannot imagine. At MIT's Department of Astrophysical Research, models suggest that comets passing through dense regions of dark matter might experience small accelerations. Not measurable by instruments, but significant across eons. If so, then 3I's Atlas will eventually pick up speed, drawn subtly toward new regions of gravity, new stories yet untold. You might imagine it like a leaf floating across invisible currents, occasionally nudged by soft eddies in a stream you cannot see. There is no destination, only continuity. That is what dark matter gives the universe. Endless motion without chaos, direction without destination. As you listen, breathe in deeply. Let the air fill your lungs like the invisible gravity that fills the cosmos. You are held by unseen forces too, by time, by energy, by the quiet structure of existence. You don't need to see them to trust them. They have always been there, keeping everything in balance. Somewhere in that invisible ocean, the traveler continues to drift. It will never stop. It will move forever, wrapped in the unseen hands of the universe's first dream. Nothing in the universe ever truly ends. Stars die, but their dust becomes new suns. Light fades, but its energy is reborn in other forms. Every path is a circle, every journey a return. For 3I Atlas, return does not mean coming back to where it began, but completing its purpose. To move, to witness, to continue. After millions of years of wandering through the galaxy's arms, it will one day curve gently back toward another region of starlight. Not our sun, perhaps, but some other distant star that has not yet formed. Astronomers call this phenomenon galactic recycling. Objects thrown from one system eventually join another, carrying with them elements that seed the creation of new worlds. 3I Atlas may one day be part of a newborn solar system, its atoms fused into planets, oceans, or perhaps even life itself. Everything returns. In the Journal of Interstellar Chemistry, a recent model suggests that nearly 40% of the material in stars like our sun once belonged to other galaxies. It means that we too are part of someone else's return, fragments of forgotten systems reassembled into this one. You are made of ancient stars. Your breath, your bones, your blood, all once drifted like 3I Atlas through cosmic seas. And when your warmth fades one day, your atoms will join the same current, returning again to light. There is no loss in this. There is only change. There is only motion and rest within that motion. If your body feels heavy now, let it. That weight is the earth reminding you that you are part of the same gravity that guides comets through space. You are already home.